Good morning, ladies and gentlemen. We're about to start. A very warm welcome on this very early start on a Monday morning, ahead of a very important week here in Bangkok with the Health and Nutrition Exhibition, along with VIV Asia 2026. It's great to be here. We've held these aquatic events several times now, and there's a great demand for it. I'm just seeing my first speaker walk in the door, but we might have to change the program slightly. My name is Roger Gilbert. I'm the publisher of International Aquafeed magazine and the directory, and you have a little card on your table there that you're welcome to take with you that gives you access to our magazines free of charge. I would like to welcome you, but I also know it's very important for Natasha Hall, who is the new VP of VNU Europe. Many congratulations, to welcome you as well. We share this conference, and VNU, through its VIV activities, etc., is very supportive of these types of activities. But welcome, Natasha.
Thank you, Roger, for the introduction. Good morning, distinguished guests and colleagues. It is a pleasure to welcome you here to the Aquatic Conference at H&N Asia this year. I am Natasha Hall, as Roger has already introduced myself as the Vice President of VIV Worldwide. And it's really great to see you all here and to be able to run this conference on a yearly basis in Bangkok, besides VIV Asia, which you might be more familiar with already. So for this edition, we have a very exciting lineup of speakers and panels. They will be exploring the latest innovations, challenges, and opportunities in the aquatic sector, from sustainable aquaculture practices to the latest advancements in marine technology. We are really thrilled to have you here to share that knowledge, to network, and to drive the progress in this vital sector. So let's make the most of our time here together. And over the next few hours, I really encourage you to take part, to engage, to network, ask questions, and really forge those new connections that will propel this industry further. So without further ado, thank you, Roger.
Yeah, thank you very much.
Have a good conference.
Thank you, Natasha. Thank you. Thank you. Okay. You can pick up copies of our magazines just in case you want the copy itself at the door there. I have 10 speakers today, or we have 10 speakers today, 5 in the morning, 5 in the afternoon. We break for coffee after 3. Our first speaker is Joe McDonald. I know you've just walked in, Joe. If you're relaxed enough to kick straight off, you're okay? Because we could swap around and give you a few minutes if you need them. Okay, I want to get on with the program because we want to stick to time. Our first speaker is Joe McDonald here. He's from Vericon Aqua out of the UK. He's going to be addressing state-of-the-art on-farm algae production, the impact on performance and quality. Joe brings over 4 decades of multidisciplinary experience focused on aquatic biotechnology. His expertise spans project management, business development, live feed production, finfish cultivation, behavioural ecology, and algae production dynamics. Today he is the owner and CEO of Vericon Aqua Solutions. He runs a photobioreactor company, engineer, ONC in bioscience. He serves on Algae UK's board and EABA's committee today. Joe,
Thank you, Roger. Sounds like I know what I'm doing. So good morning, everybody. It's a pleasure to be here, to have an invitation to talk at the conference today. What I want to do today is just to share some information on the progression, I guess, of algae production technology. I mean, over the last 100 years, I guess, in aquaculture. There's obviously a lot of development in biotech as well, which I won't touch on today. So I'm just going to really talk about those kind of 3 approaches: extensive, semi-intensive, and intensive, which is where I really focus as a business. But historically, in my early days in fish hatcheries, I was working on both extensive and semi-intensive production as well. So I have reasonable insights in that space. So just a quick little bit about us. So we have a whole range of different photobioreactor types, which again are all designed to improve performance, consistency, reliability. And around that, we've developed a range of nutrient substrates which also feed into the system, which take away the inconsistency and de-risks that part of the production as well. So it's a complete package. And we deliver globally, everything from small systems, a few litres, up to millions of litres of productivity. So this is roughly what we cover: consultancy, digital AI, downstream, nutrient consumables, photobioreactors, and of course a lot of systems for aquaculture as well around live feed production. So in terms of on-farm production, I'm pretty sure everybody here is familiar with this, but shellfish hatcheries are working a great deal on flagellates and diatoms. Marine fish hatcheries tend to be things like Nanochloropsis, Isochrysis pavlova, and then green algae as well, Neochloris oleobundus, and these sorts of things for fresh water production. So in terms of okay, do you want to put that closer? Okay. So in terms of production systems, you have extensive, which are open ponds. They still exist today, of course. Using natural sunlight, organic or inorganic nutrient substrates, mixed species, low control, typically inconsistent biomass quality and densities, and these are typically for extensive fish and shrimp pond production. The artisanal is more in the marine hatchery space, where higher densities, higher numbers of juveniles are produced, so of course you have to move to a more reliable system, which would be artisanal. Still, small volumes using Guillard's F/2 as the standard media, in some cases using walm, sometimes known as Conway media. And again, either using natural sunlight or artificial light, historically things like sodium lamps, metal halides, and of course fluorescence. It's moved on since then. So in terms of intensive, there's still bag production, which is, in my opinion, semi-intensive, column reactors, annular reactors, and of course serpentine tubular photobioreactors. And of course there are some other intensive enclosed photobioreactors as well. And the beauty of these is that they're very scalable and very controllable, and that's what I want to try and illustrate today. So this is something you'll be familiar with, batch and semi-continuous culture systems, fairly extensive, reliable but inconsistent. Then moving on to classic bag and culture systems, again, anybody who grows algae will be familiar with that kind of classic production chain. Everything from Erlenmeyer's could even be on agar slopes if you want to run a much cleaner system, or through to starter cultures and then scaling and then up to bags. And a lot of the bags are all in, all out. It's a 5 to 7 day batch culture, but in some cases these are run as semi-continuous, where you might harvest 10 to 20% of the culture a day, and then re-inoculate, restart again. In terms of where I'm placed, we are working very much on a more intensive production system, utilising a lot of glass tubing. This is the standard these days in a lot of nutraceutical production, cosmeceutical production, food, feed technologies, because it's much more reliable, has a very nice life cycle analysis, and again, very scalable. This is one we built in Japan for a company, for example, focusing on production of Pavlova lithuri, and this is a nutraceutical product, and also for fucoxanthin extraction. This was built outside. The stainless steel cage is to protect it from typhoons, so this works 24/7, shading, cooling, typhoon protection. So it's a very flexible technology. Again, if one looks at the types of densities, and this is really where the progress has come, artisanal systems where you're 50,000 maybe to 800,000 cells per ml, all the way through to intensive PBRs for diatoms where you are tens of millions of cells per milliliter. So it's significantly different. If you're looking at flagellates, this is very, very different. Flagellates are much easier, in my opinion, to produce than some diatoms in the types of systems we build, but we're still up at the top end, up to 60 million cells per milliliter. This is Isochrysis, in fact, which is typically in bag culture, 10 to 20 million cells per milliliter. So it's a great way of boosting productivity on a smaller footprint and with greater control and consistency. And then again with green algae, this figure here is at the top end here, 600 million cells per milliliter. This is Nanochloropsis. You would never produce it at that density, that's just peak, but typically In a high density system, you'd run that somewhere between 150 say to 200 million cells per milliliter. At a relatively high harvest rate, could be 20, 30, 40% per day, depending on the light input. So, and then this little diagram here just reflects the influence of light path on productivity. So effectively, the deeper the light path, the lower the density you can achieve. Whereas, if you're looking at a relatively small, 32 millimeter, 65 milliliter, the data here for the Nanochloropsis was actually in 110 millimeter in Indonesia. But typically the systems we're delivering are 54 to 65 milliliters, so very, very high production density. So that correlation between light path and optical path is perhaps the biggest driver in terms of performance, specific growth rate. So in terms of the strengths and weaknesses of the different systems, artisanals, low cost, simple setup, accessible to communities, uses natural sunlight, and is relatively flexible, but it's an all-in, all-out sort of approach. Intensive hatcheries, higher densities, more so than artisanal, using controlled aeration and nutrients which are typically based on standard recipes, I said F/2 or WOMS, more consistent production, and scalable to some degree. If one looks at photobioreactors, these are all photobioreactors, but in the sense that these are more engineered, tubular systems, ultra high densities, more biosecure, not necessarily sterile, garbage in, garbage out is always the approach. And then precise control of growth, so a lot more data acquisition and control, a lot more AI and machine learning come into interpreting performance and optimizing that, and then optimize nutritional performance. With intensive systems, you can change the temperature, change the pH, change the harvest philosophy, change the lighting, change the nutrient substrates. So you can actually manipulate the composition. You can starve them for nitrogen and increase lipid content. You can increase the nitrogen, increase the protein content. So there's lots of flexibility in there. In terms of weaknesses, artisanal low productivity, vulnerable to contamination, of course, seasonally dependent, and the nutritional quality is less consistent. Intensive hatcheries, higher operational costs, requires some skilled management, of course, still vulnerable to contamination, and has limited scalability. The photobioreactors, higher capital investment, requires skilled management. At face value, it can appear energy intensive and can require a greater infrastructure. And I just highlight that caveat there. Yes, the energy cost is higher, but the productivity is much, much higher. The quality is much higher. So there are all of these unforeseen benefits where if you're feeding that into a larval rearing system, better quality, lower bacterial count, the cost benefit analysis is much more complex than just a CapEx, direct OpEx scenario. Excuse me, the opportunities. The artisanal is accessible to everybody. You don't need a lot of capital investment. It integrates well with shellfish and shrimp farming. Low cost training and education. That's not necessarily true. There are lots of very, very smart people running extensive systems. And in some cases, it can bring food security and community resilience. Intensive is the bridge between artisanal and industrial. It can support regional aquaculture hubs. There's some standardization in the hatcheries, and it's a mid-level solution. It's where we were, it's where some people still are, but as a business, we're trying to push people to look more at technological solutions. For the industrial PBRs, as I say, it's industrial scale. We can deliver you a 3-litre system or a supply chain that takes you to multiple millions of litres. And in terms of CapEx, if you're looking at, say, a 1,000-litre glass tubular photobioreactor, if you buy from me, it's probably somewhere in the order of about 50 or 60 pounds per litre deployed, installed. But if you then move to 100,000, 200,000, that very rapidly comes down to £6 per litre deployed technology. So there is a significant benefit of scalability. May not fit with a lot of hatchery operations, but there's always an intermediate solution. It is greater reliability and performance, of course, so it's more hands-off, less people. You can set it to run, and it should run. Integration with automation, of course, so it can also be integrated into your building management system via the HMI, whatever you want to do that way. And it mitigates, as I said, that risk around staff. If you have staff sickness, staff absence, it's a holiday, the system just makes algae. You don't need to worry about it. Threats, artisanals, obviously climate variability, risk of culture crashes, limited competitiveness and reliance on the weather. Intensive hatcheries, you have a rising energy cost, disease contamination spread because it's quite intensive in that space. A lot of these systems are open. Competition from modern PBRs, the sort of technical solutions that my company delivers. And then operational error. You know, people in many cases are frequently the problem in fish farms. I run fish farms for years, and you know, the people on the farm, if they don't do the right thing, can have a major negative impact or a major positive impact. Intensive systems, there's still a contamination risk. If you don't pay attention to the inputs, you'll contaminate it. And that's just the reality of the world. So very, very strict protocols are necessary. The more intellectual and intelligent you go, it requires much more focus on the detail, which means your people need to be much better trained. Key component failure. There's a lot of moving parts. If a component breaks, that's a risk. Over-specialisation, again, if you don't have people on the farm understanding the technology and how to operate it, that's a risk. And of course, it's dependent on infrastructure. If you have a power failure, then you have a problem because it's super intensive. So in summary, artisanal, low cost, community-based, limited reliability. Intensive is mid-scale, controlled, more expensive. Industrial PBRs, of course industrial, ultra-high density, consistent, more expensive and complex. So I just want to touch on the nutrient part of it, because that's an important part of the input. That's the feed for the microalgae. So there are lots of different substrates used, lots of farms have their own recipes. But what I tried to do was to look at what are the standard recipes and redesign them, because I used to work in the hatcheries. You take a boiling flask, you add your nitrate, your phosphate, then your trace metals, and then your vitamins, and you have to mix them all, and it can be inconsistent. So I just really didn't like doing that. So I went back and looked at the chemistry, redesigned it. So these are all chelates. It comes in a pre-pack, everything's in there. Elementally, it's identical to any of the other medias that you would use, and it's off the shelf, and it has a very long shelf life. So it takes away that inconsistency, and it also takes away the risk in the lab for the people working with the glassware and hot surfaces and different things. So we've developed a range of products, F/2, and I know there are other commercial products in the market which tend to be liquids, but ours is a dry product, chelated. We have Walms, which is also referred to as Conway. Then we have a Cell High Bio, which is an organic certified substrate. Doesn't really fit with an aquaculture environment just because of the composition. We have a Nematococcus product, which is used in nutraceutical production. We have a Jaworski, which is used for producing chlorella and other cyanobacteria. And then we have a spirulina media as well, which is more of a commercial product. So these are all sachet, available in kilo and available in tons. So in terms of the approach, improved productivity because it's consistent, it is competitively priced compared to actually doing it on farm yourself. Of course, labour is a big part, so if you're very, very cheap labour, then maybe the economics are questionable, but it's still highly reliable. It's easy to dose because it's fully soluble. It has a very long shelf life, as I say, 2 years is our recommended shelf life, but I mean, we use product that's 5 years old in our own labs. Reduced transport cost, it's a dry product, so you're not shipping liquids. Low impact, so it's got a very low storage space, and it's highly customizable. So, you know, if anybody here was a major producer and they asked me, Joe, can you make an analogue of what we have, then the answer would be yes, we'll have a look at it. So we do specialist manufacturing. So just here to highlight the composition, in terms of microalgae composition, it can vary greatly based on species, biotic and abiotic conditions. They're an important part of the feedstock in the hatcheries. As I say, high protein content can be important, high lipid content can be important, high pigment content can be important. So again, what we've done is to formulate a media that meets the biological requirements of the microalgae. So again, just looking at the typical composition of microalgae versus the composition of the nutrients going in. If you don't put it in, you can't put it out. I mean, algae can synthesize lots of things, but they have to have the base chemicals there to do that. In terms of the economics, again, take this with a pinch of salt. You know, data is always hard to find and quite limited, but what we've tried to do here is to just illustrate the cost benefit of using a highly formulated product which has a high capital cost, because we're buying nutrients in Europe. I mean, I think if we bought them in Asia, it might be different. But the labour cost element is the important part of it, which, you know, again, I know running marine hatcheries, you know, people's time is very, very important, and you don't want to be spending hours mixing batch after batch and holding lots of chemicals. So this is an off-the-shelf solution. Put it into deionized water, mix it, and away you go. So that's what that is there. So again, looking at its performance in particular for shellfish, for crustacea hatcheries, this is just a detail on performance. We compared this with another commercial product, a two-part liquid product, and just to illustrate the sort of performance that you can get. So this was with Chaetoceros mulleri, and you know, achieving pretty high optical densities and pretty high cell densities, so 30 million cells per milliliter. And then what I wanted to just touch on, we haven't really touched on this, it's a whole different topic, is what's the actual influence of the microalgae on the performance of your shellfish larvae, your marine fish larvae, your rotifers, your copepods, whatever it is you're rearing in the hatcheries. So I just did a quick look on, in terms of bibliography, just to pull up some papers on the relative influence, and I'm talking here about quality, survivability, growth, you know, meat quality, broodstock performance, all of these sorts of things. So that's just a little bit of information on that there. And then just in summary, from my point of view, with algae production transitioning from green and brown water, extensive, of varied quality and density to state-of-the-art photobioreactors and ready-to-use nutrient formulations, today's algae production now achieves ultra-high densities and biosecure closed systems with precise control and optimized nutritional profiles. Algae production technology has indeed come far, and now can truly support the algae predictability and quality of the ongoing blue revolution in bivalve shrimp and finfish aquaculture. And that's it. Thank you very much for your time.
Thank you very much, Joe.
20 minutes.
Exactly. Thank you.
Thank you very much.
Unless there's a pressing question, we have a Q&A session at the end of the day. But are there any pressing questions of Joe at the moment? Okay. Yes, we have one down here. Please use the microphone. No. I'll bring one to you. There we go.
Hi, good morning.
Yeah, good morning.
The product that you mentioned, that applies to any system, the artisanal, the intensive, and
the photobioreactor or the nutrients?
No, I mean the product that you mentioned, that is all-in-one.
Yes.
It can be used on any system.
It can, yes.
Is there a dosage for each system?
There is, yes, yeah. And
So
we
it's
have
different.
Yeah, I mean, it depends on the system. I mean, because it's a mass transfer, isn't it? So if you're producing, let's say, microalgae in an open pond at 0.05 grams per litre, then you only need a fraction, a proportion of the quantity, the dry weight quantity per litre. So for us, a standard production system, batch production system, would be, say, to target nitrogen, nitrate at 75 milligrams per litre. In an extensive system, we might say, okay, 20 milligrams per litre is adequate. In our intensive systems, we could be 750 milligrams per litre, because it depends on the specific growth rate. So you've really just got to look at what the what's the mass transfer rate and how much do you need to add to achieve that biomass productivity at the back end. But in an extensive systems, we have a product called Tevit. It's a trace element and vitamin substrate, so where you're using extremely large ponds, it could be a hectare. Our product's way too expensive. You're not going to use it in that system, so you'll use other industrial type N's and P's. But what we can bring is that key part, which is the trace element and vitamin element, which goes in at a relatively low, I think it's 3.2 milligrams per litre in extensive systems. So it's an extremely flexible product.
So the first thing I'd like to say, I actually put this title together a few weeks ago when the world was a very different place, of course. So I hope I haven't contributed to any increasing security concerns. But I think it's really important to address the topic of endotoxins, or what we will think of the bacterial weaponry. Because very often when we're focusing on health, we focus on the bacteria themselves. So we're looking at what is our Vibrio count. And very often we know who is there, but we don't know what it is doing. So there's two questions: who is there and what is it doing? So this is what we will cover in the topic today. So what are endotoxins first? let's all start off on the same page. So endotoxins are basically large macromolecules. They can be considered LPS or lipopolysaccharides, and they make up the membrane of gram-negative bacteria. Like I say, they're very big macromolecules, around 10 to 20,000 kilodaltons. And just to put that into perspective, if you think about water, H2O, this will be around 50 daltons. So it's around 500 to 1,000 times bigger than a molecule of water. They contain 3 parts. So if we look at lipid A, which is on the right, this will be the bioactive part, and this is the anchor in the cell. So this is what is attaching the molecule to the cell. And this is the what is making the toxin toxic. So this is the dangerous part of the molecule. And then you have another few parts, and depending on the type of the endotoxin, will determine exactly what that characteristic is. So generally speaking, we can consider 2 types of endotoxins. There's the smooth, and then there's the rough. The smooth will be the wild type, the naturally occurring one, and then the rough will be the mutated form. There are some differences, and there's also some similarities. Both are occurring in nature. Both can cause problems to ourselves, to our animals, but the rough LPS is much more dangerous. And I will come back to why this is important later. So rough LPS has much higher reactivity for our shrimp, for our fish. The effects of endotoxins. So I'm going to go through this quite quickly because, of course, there's many, many different effects. It depends on the toxin itself. It depends on the level of the contamination, the level of the exposure, how long the animals are exposed to that. Is it an acute exposure? Is it a chronic exposure? It depends on the nutrition, the environment, the animal itself, of course. And in 20 minutes is really not enough time to go through that. But I will focus on a couple of things, of course, focusing on shrimp. So toxins themselves, the endotoxins will be naturally occurring, like I mentioned. They're coming from the general breakdown, the life cycle of the cells in the pond, specifically Vibrio. And then they can come into the shrimp as the shrimp are eating, as the shrimp are drinking, sometimes, usually through the gut, but also through the gills, and sometimes through the skin, especially when the shrimp are molting. Can come in through wounds and lesions, and also through injection, of course, for R&D purposes. What's really important, even if the Vibrio count is stable, we will still have a certain level of endotoxin there. So even if we think our ponds are stable, we think our shrimp are safe, there's always this overlooked and maybe underappreciated threat. So how do shrimp detect LPS? Actually, it's kind of back to school in terms of immunology here. It's not that different to how they're detecting pathogens. So of course, we have our gram-negative pathogen up here. So this could be a Vibrio, for example. There'll be a number of different markers or receptors on the cells of the gut or the hepatopancreas, many, many different types. And once they get detected, that will trigger an immune cascade through a number of different adapter proteins, transcription factors, and you end up with your immune response. And that can be humoral or it can be cellular. So if we look at the humoral one, mostly we're talking about the prophenol oxidase. This is the system which is most important for the shrimp. So what will happen, our Vibrio will get detected by one of these PAMPs, this pathogen-associated molecular pattern, and then a whole serine protease activation will happen, which then cleaves the pro part of the PO. So the phenol oxidase part will then contribute to the melanization, and this melanin will then be deposited around different parts of the invading pathogen, and basically forms this physical barrier. So that's the important part of how they're recognized from a humoral side. But then, of course, we have our cellular immune response. So in shrimp, we're talking about 3 main classes of white blood cell or equivalent. We have the hyaline cells. So these will be important for the engulfing of the pathogen or the endotoxin, so basically absorbing it. Cellular granule cells, which are important for encapsulation, especially of larger invading pathogens like a parasite, for example. And when it comes to the propo system, the granular cells are the most important. So these kind of dots, if you like, these granules, they'll be filled with different enzymes, different antimicrobial peptides, and they will also be directly removing the pathogen, but also supporting the propo system as well. And then, like I mentioned, there's always a natural occurring level of endotoxins. And we can say, this is good or is it bad? There's always this argument like, is immune modulation or immune stimulation, is it good or bad? Well, actually, if we look here, this is a kind of a endotoxin concentrations on the y-axis, and then you have without the Vibrio challenge and with a Vibrio challenge here. So you see in the control, there's always a certain level of endotoxins in the animal, which I would argue is a good thing, because a little bit of stress can be a good thing. You want the animal to be not stimulated, but modulated. But what happens when the Vibrio comes along, you can see these endotoxins in the hemolymph increase very, very rapidly. So a little bit of modulation, stimulation, if you like, is a good thing, but too much can be a very, very bad thing. And then, of course, it leads to your impaired disease resistance and mortality. So we know it is there. We know that causing problems to our animals. The next question is, what can we do about it? And luckily, there's a number of different solutions on the market. So firstly, in terms of our LPS, I'm going to talk about E. coli. And there's a reason for this. As a company, but also as an industry, E. coli is very, very well understood. Because, of course, it's the major pathogen for chickens, for pigs, even for humans and things like that. So actually, this is some data that DSM had a long time ago. We know that with our bentonite, we can bind LPS from E. coli. And you can see the binding is more than 90%, even higher in some cases, with and without mycotoxins. So we know that, we can do that, and we've demonstrated it very clearly. By the way, the method that we are using is the LAL assay. So we're taking the hemolymph from a horseshoe crab. It's very, very good at detecting endotoxins. And then it will basically clot, coagulate, and change color. And that's how we can see how much has been bound. So with E. coli, we can work very, very easily. We can make a phone call, go on the internet. We can buy LPS from different suppliers. It's super easy. The problem is, you cannot commercially buy Vibrio LPS. So this creates a huge challenge for us. So 18 months ago, even 2 years ago, I talked to our scientists and I wanted to understand what we can do about this. And they said, no problem, we can use E. coli, we can use Salmonella. I said, look, we are aqua people. We like to talk about aqua topics. Nobody cares about E. coli or Salmonella really in the aqua industry. So we need to use LPS from Vibrio, but from a very specific Vibrio, Parahemolyticus. So with that request and with a little bit of encouragement and reminding, some very smart people much smarter than me, they started to characterize and get hold of LPS from Vibrio Parahemolyticus. And here's 2 ways that we characterized it. The details don't really matter here, but the most important parts are here on the left. We're looking at the size of the protein itself. So here, this is smooth LPS, and here we have the rough LPS here. And you can see Vibrio Parahemolyticus is pretty much exactly the same as Salmonella. And it is a rough LPS. And then I come back to what I said at the beginning, rough LPS is the most toxic, the most dangerous for shrimp. So we know that it's a rough LPS. Secondly, we want to do a characterization of the molecule itself. And here, we have to trust me when I tell you this, because I still can't see it myself. But the lipid A part, the part that makes the toxin toxic, is pretty much exactly the same as the E. coli as well. So the LPS, in summary, of Vibrio is very, very similar to the LPS of E. coli and Salmonella. And with that, we can then go back to our original plan, utilizing the hemolymph of horseshoe crabs. And instead of using the LPS from E. coli, this time we're going to use LPS from Vibrio. And we get great results again. No difference in terms of binding from E. coli and binding from the Vibrio Parahemolyticus. So basically what we are saying, a bentonite can neutralize endotoxins not just from E. coli, but also from Vibrio as well. So that's great. LPS is important, endotoxins are important, but also, especially when we're talking about Vibrio, we also have other toxins. So we're talking about binary toxins here, the peer A and the peer B. So with that in mind, we know we can bind the endotoxins. Can we bind binary toxins, the peer A and the peer B? And I think you know where I'm going with this. I wouldn't be here to present the data if we couldn't. So again, with a huge amount of work in the background, this is a very, very simple graph. But to get this, it took over, I would say, 6 to 9 months. Because again, you cannot buy PRA. You know, we have to work with a number of different partners to really get hold of the toxin, to purify that toxin, to make sure it is actually what we think about it. And of course, PRA is very often linked with PRB as well. So we need to make sure we're working with the actual toxin we think. But again, using this bentonite, we can bind more than 90%, I would say, of the PRA. So we're starting to develop the story. We can bind LPS, we can bind PRA. But what about PRB? Because PRB is probably a little bit more toxic than PRA. Of course, they're usually co-occurring in nature. So we then changed the methodology a little bit. Instead of using PRA, we're using PRB this time at 2 different doses. And again, you can see a very high binding affinity of the bentonite when it comes to PRB as well. So that's a really nice story. We can use the bentonite to bind Vibrio LPS, PRA, and PRB. So it's a very, very useful tool for our health management programs. But I'm talking about bentonite. You know, everybody has a bentonite these days, you know. So probably maybe some customers in the room here, they're saying, I'm using a bentonite already, so I'm protected. Or maybe there's some suppliers in the room thinking, great, thank you, DSM. You've spent all this time, all this money, and you've given me some great sales arguments. But unfortunately, a word of warning, not all bentonites are the same. So, I mean, bentonite is just here, but there's many, many different binders. So again, not all bentonites, not all binders will be able to do this. So ask your supplier for data. Data is king. And just to demonstrate this, we took these test products. We're not using the product name, but if you're interested, this is MycoFix here. And again, going back to our core expertise, if you like, with mycotoxins, you can tell these are all inorganic binders, some of which here, MycoFix is very, very good at binding the mycotoxins and indeed the LPS, the PRA, PRB. Some of them are pretty useless. And again, the same when it comes to these mixed products. So check your bentonite. Bentonite isn't always bentonite. Very simple clay, but it's not always that simple in reality. So I think I'm on time. You have the watch, Roger. Just as some take-home messages, endotoxins, just like Vibrio actually, they're always present in the environment. So let's not bother to remove them. There's no point in doing that. Let's allow our shrimp to survive and thrive despite this pressure. We know endotoxins can cause problems in our animal through the immunity, impairing the disease resistance, making them more susceptible to other diseases in the environment. Vibrio parahelminthecus LPS is very similar to E. coli, which is really good for us now because we don't need to spend so much money getting hold of it in the future. Binary toxins, PRA, PRB, can also be bound by some bentonites, I would add here, not just bentonite. And very, very importantly, not all bentonites are the same. So if you...
Morning, everyone. I'm kind of scared to talk about this topic because it's new for me, and then I took this challenge to get out of the comfort zone. I don't say new, but deep is new. Like I didn't go like to the Marianas Trench. I was swimming on the surface. So this time I tried to dig deeper a little, right? Last 3-4 weeks. So pardon me if you know some of the stuffs that I will talk, and maybe some of the stuffs are new. So we'll try to move. So lipid, right? Fat, lipid, fatty acids, everything is in there. So what are lipids? So lipids are a broad group of hydrophobic or amphipathic, which is like hydrophobic and philic molecules, essential for life as energy source, store, structural components of cells, and as well as signaling molecules. So our hormonal regulations, lipids also play an important role. So types in aquafeed, right? We have triglycerides, which is glycerol, and with 3 fatty acids. And we have phospholipids, which is glycerol with a phosphate molecule and 2 fatty acids. The phosphate kicked out 1 fatty acid. We have 2, and out of the 2, 1 is saturated and the other is unsaturated, right? So it's a limping molecule, you can say. So phospholipid is kind of a limping molecule, right? One is saturated, another one is unsaturated with 1 double carbon bond, or 1 or more double carbon bond. Then we have liposterols, right? So that's cholesterols is one of the sterols. There are also phytosterols, and they are normally ring-shaped molecules, and they play a role in hormones and as well as membrane fluidity. And finally, we have glycolipids. And all these molecules, the key component is the fatty acids, right? Which is long carbon chains with carboxyl group, right? And plays a major role in building blocks and energy. So phospholipids, what do? They enhance digestion and absorption of other lipids. They are vital for growth and good health of aquaculture stocks, and they're important for crustaceans, as we all know, and early life nutrition. And I'm expecting some questions on this at the end, maybe at the end of today's session, because I have some new insights to talk about, which I'm not going to divulge in my talk. Thank you. So fatty acids, they're a little bit obscure but essential because they are hiding most of the time within different molecules, right? As we discussed earlier. And there are three different kinds, as we know: saturated, monounsaturated, and polyunsaturated. And there's a long list of stuffs, right? And we all know this guy could be, in terms of monounsaturated, only one double bond, and polyunsaturated is two or more double bonds are polyunsaturated. And highly unsaturated, if we go, that's EPA, DHA, and ARA. There's more than three actually. Like you have EPA is 5 double bonds, and DHA has 6 double bonds, ARA has 4 double bonds, etc. So what really matters, right? It's interesting thing about the palmitic acid, as we know, in dairy nutrition we use palmitic acid. So I was like, why we use palmitic acid is palm fat in dairy nutrition, right? And that's the molecule that it can elongate to long chain like monounsaturated fatty acids and the longer saturated fatty acids as well. So palmitic acid kind of acts as a central hub in terms of fatty acid elongation. And if you look at the enzymes involved in fatty acid, there are a lot of enzymes involved in fatty acid elongation. And for omega-9, you see there's acetyl coenzyme A, moves to, with palmitic acid, then with elongase, you have stearic acid. And from stearic acid, you get one double bond, and you have oleic acid. Same goes for omega-6 and omega-3. You have a lot of enzymes involved in the process of elongation. Now, digesting lipids, right? So how lipids are digested? The stomach, the minimal digestion happen, and the intestine is the main site. And for digestion requires emulsification, bile acid, and enzymes. And there is a huge difference, we know, between fish versus crustaceans. And we'll be answering some critical questions at the end of today's session. Thank you. That's the gap I'm trying to, sorry. Emulsification is the first step, right, of the lipid digestion. It creates droplets to increase area for lipase to act and to break down to fatty acids maybe, and essential for larvae and shrimp as they lack bile. And there are so many different types, and we'll have more on this at the end, close to the end of this session. Okay. Now, emulsification is the first step. As I said, this is one paper that it reduces 10% reduction in fish oil from positive control. And as you can see, there's two different levels, right? NC plus negative control plus 0.03% of lysophospholipid, and negative control plus 0.06% lysophospholipid. So a little bit of addition can improve the growth and other performance parameters than from negative control, even when you reduce the fish oil. So there's a improved fat digestion. Due to improved fat digestion, we can reduce the expensive fish oil from the diet. There are other issues as well. When you, for example, for shrimp, there was a zero fish meal diet. So you can have a zero fish meal diet when you increase the fish oil as well as some essential amino acids. So you will not lose the performance. So bile salts and lipase. So bile salts form micelles, right? And as you can see, micelles are like a fatty acid molecule. It's like with phospholipid, right? And they come together and they form the micelles, and they pass through the intestinal epithelium, right? And the issue is that, as we discussed in earlier slides, that shrimp produce very little bile, and in that case, enzyme supplementation can help. There are different kinds of lipases, right? There's a huge range of different kind of lipase coming from lingual, so in the mouth can be digested a little, and then you have gastric lipase, pancreatic lipase and then you have co-lipase, right? It's a cofactor for lipase. You have pancreatic lipase, the whole range of lipase enzyme that act on different phases and different locations. Okay? And now the intestinal, how the digestion happen in intestine. So with the help of bile acid, the micelle form, right? And then the triacylglyceride, which is a common form of lipid, break down with, to monoacyl glyceraldehyde, phospholipid, and cholesterol with the help of enzymes. And in the course, we also get some free fatty acids. But what are the issues with lipid digestion, right? We have limited emulsification capacity, we have variable lipase activity in the animal, and we have poor utilization of plant-based lipids because we are using a lot of plant-based lipids. And when I see, right, we are using marine fish oil coming from the fish processing industry. If you look from coming from Norway or coming from Chile, right, they use 50% plant oil and vegetable oil and 50% marine oil. So what we get from those salmon processing industry, actually 50% plant oil. So when we formulate our diet, we do another 50-50. So actually we get 25% of marine oil, just simple calculation, right? So we need to focus on how we can, there's a deficiency, right? Because we are using 2% of fish oil coming from Norway or Chile, which actually contains 25%, right? So we have 0.5% of actual fish oil in the diet. So we need to think about this, how we can mitigate these deficiencies, right, in our diets. So other issues are limited ability to elongate and desaturate fatty acid. Stress is a big factor. It can affect the ability to digest lipid properly, and then immature digestive systems, right? Now coming to lipid after digestion, you have absorption and assimilation, right? This is the process. So the first is absorbs through diffusion of micelles, as we discussed earlier, through an steel water layer, and it then pass to digestion products through plasma membrane of enterocytes through simple diffusion. Then we have cytosolic activation and esterification of fatty acids. Then formation of chylomicrons and lipoproteins. Then, as we know, in our blood, it goes through very low density lipoprotein and high density lipoprotein, or LDL and HDL, as we know, right, for cholesterols. So we measure these two parameters for our, the quality of the lipids in our bloodstream, and then health status as well. So assimilation, right? In the cell, we always normally have 80% of triacylglyceraldehyde. So if there's a positive balance, if you have more than 80%, they are deposited into adipose tissue. If there's a negative balance, these triacylglyceraldehydes are taken from adipose tissue. And now what is happening inside the cell? This is the Professor Thiam. He's the laureate of Lillian Betancourt Prize for Life Sciences. And for this discovery of like the lipid regions in endoplasmic reticulum and how they play a role in terms of lipid metabolism. And if you look at the function of endoplasmic reticulum membrane, so lipid droplets are originate from the membrane, and neutral lipids accumulate between the two leaflets, and they bud off as droplets. So I was discussing with someone yesterday about the lipid droplets, right? In the farm, for shrimp health, we look at the droplets size or numbers of droplets in the hepatopancreas, right? This is a critical thing that we look at. So sometimes we think, okay, we have a large droplets, so lipids are digested. So larger droplets is not basically a good indicator. So the frequency and then homogeneity of the size of the droplets is important when you look at the health of the shrimp. That was one of the insights I got yesterday. So there are a lot of lipid transfer proteins acting in the lipid metabolism. This is a human study by Titaka et al. This published this year. There is about 131 lipid transfer proteins. So very complex mechanism. So we cannot talk all about this. It's unfathomable for me still, right? I'm just thinking there's 131 proteins involved into lipid metabolism inside the cell. So how can we improve lipid utilization, right? You can use emulsifiers, as we mentioned. There are a lot of different kinds of emulsifier, like glyceride-based emulsifier, right? Mono and diglycerides, distilled monoglycerides, etc. Polysolvates are used for vitamin A, D, E, and K emulsion. They are also used for essential oil carriers, right? And they are used as a liquid feed supplement. And there is a cellulosic and hydrocolloid emulsifier, commonly lecithin and phospholipids. We use soy lecithin, we use hydrolyzed lecithin, etc., right? And there are also propylene glycol and glycerol. So interesting thing about propylene glycol, like this last winter, I used this one in the diet in tilapia diet for cold temperature, right? So, and then I saw that the intake was much better even at lower temperature with this product. It's a kind of an insight because I don't work for anyone. Thank you. So for emulsifier, not all are the same. And the critical point is HLV value, which is hydrophilic lipophilic balance value. And for better emulsifier, oil in water emulsifier, which the value should be between 6 and 14, right? So you have to ask for the HLB value when we are buying an emulsifier. And then we can have a simple test like this one and keep them for between, say, 2 to 12 hours or 14 hours and see the, how they are being separated or not, how much is separated or how much is emulsified, etc., to look at the quality of the emulsifier. Okay. Then bile acids, there are different kind of bile acids, cholic acids, CDC, as you said, that's you can buy all these things from different companies, and there are also bile acid blends, right? So bile acids are valuable when diets contain high fat or low digestible fat, and when animals are young with immature bile secretion, as well as when they're under heat stress or disease, reducing digestive efficiency. So bile acid can be helpful. And aquaculture species require precise lipid. And the requirement of bile acid sometimes, again, insights from yesterday's discussion with one of the experts. I can tell the name, you all know the name, but that sometimes we try to use bile acids and we don't get the expected results. So we have a mixed perception about using bile acids in our diets. So the point is, we need to know when to use, like what to use, when to use, how to use, right? So everything works, but they have their own way or own way of utilization. So for shrimp, phospholipids are very important. That's what, and for fish, normally lysophospholipids are important. When there's a deficient lysophospholipids or it's not working as well, then you can add bile acid to get the improvement in the results. So bile acids could be our last resort. So phospholipids, lysophospholipids, and the bile acid, that's how we should go. Okay. So issues, right? Problems. As we know, oxidation of the polyunsaturated fatty acid oxidized very quickly. So that's an issue. There's a poor lipid digestion absorption, accumulation of undigested lipids, stress, and then finally all this translate into reduced growth, immunity, and survival. And the solutions we can use antioxidants, right? We have vitamin E, vitamin C, selenium, carotenoids. I used to tell all the time, right? When you use vitamin C for stress, also we need to increase the level of methionine. Because in the cellular level, when the protein breakdown happens, there's a ubiquitin proteasome pathway which needs vitamin C and methionine together to rebuild the proteins. So when animals are under stress, the protein breakdown is happening inside the cell. We also need to increase the methionine level with the vitamin C. All right. And we can improve emulsification by using lysophospholipids and bile acids. We can balance the lipid and PUFA. We can use high quality oil, non-oxidized. Sometimes we just, okay, if I use like we have some oxidized oil and we get like 5% mix, and what happens? It's a disaster. So we should try to avoid any kind of poor quality oil in the feed mix. Also, we have to try to reduce stress. And the benefits, we have to lower the lipid peroxidation, we have a healthy liver, hepatopancreas, better lipid utilization, we have better FCR growth, and then more profit for the farmers at the end. That's very important. So some novel strategies, these are some new papers. So that's early life nutrition. Early stage nutrition is very important, right? And now this is a very new concept coming in. It's in ovo nutrition. It's not uncommon for broiler, right? Or broiler breeder. We inject some nutrients before hatch, pre-hatch, around 18 days. And I just, for curiosity, I did some work with tilapia eggs, right? Dip the tilapia eggs after taking it from the mouth, right? Before putting them in the hatching jar for 5 minutes with some nutrient solution. And I saw 3% increase in survival, 28 days post-hatch, as well as the size was also bigger. I'm just watching this. I didn't publish this one, but I have the data. So some thinking about this strategy is that we can train our animal beforehand, maybe right after the post-hatch or even in ovo, and then we can get better performance, better immune response, and better stress management as well. Okay. So we are almost at the end. I think I'm over or close to 20 minutes. We have 3 more slides. So the solutions available, right? We can use lysolecithin-based emulsifier. For example, hydrolyzed lecithin products. We can have digestive enzyme blends like lipase, protease, and carbohydrates. We can use bile acid replacers, carnitine supplements as well, and phytobiotic blends, finally probiotic consortia. And how do we create a strategy, right? We have emulsifier, bile acids, which can improve lipid digestion. And with probiotic, prebiotic, postbiotic enzymes, or essential oils, we can improve the functions of the gastrointestinal tract, which can result in gut integrity, immunity, and stress mitigation, and which can help us to get better growth of the animal. If animals are happy, they can produce much better results, and farmers are happy. So we have to think about the side. That's what I say, right? What we do with functional nutrition is always try to manage the stress of the animals. That's what we do, try to manage the stress of the animals. So now there's a decision framework, right? If there's high plant diets, oil diets, you have to use emulsifier, bile salts, and phospholipids. Low fish meal diet, use bile acid replacers and probiotics. Cold water species or early stages, you can use lipase and phospholipids. For high energy diets for carnivores, you can use carnitine and taurine. And we can also use sustainable lipid replacements, right? For example, algae, insects, lauric acid is now coming into the play. There's a lot of products, derivatives from lauric acid now in the market as well, for disease resistance, for some, as well, pathogenic, to act against some pathogens, the lauric acid derivatives. And I think that's all with that for today, right? And I would like to thank International Aquafeed, Roger Tudi for inviting me, also Canon for help, providing the transportation for come here, and my team at Maverick. I would say now they are very professional in terms of data collection management. And that's all for today. Thank you so much for listening, and we'll hope to
aquaculture for environmentally and also the eco-friendly aquaculture production system. And then the fourth pillar is we try to supervise and control our island, because Indonesia is archipelago country. We have more than 17,000 islands, so we try to control this island. And the last pillar, is we try to reduce the pollution, the plastic pollution, the microplastic pollution in the ocean. So this is about the blue economy. And the philosophy is after we protect our conservation area, we limit the catch of the captive fisheries, and then we develop and support the growth of aquaculture. This is to supply the growing population, and then we protect our island and then reduce the plastic and also the microplastic pollution in our ocean. So that's about the blue economy. And in Indonesia right now, we have 5 primary commodities. We try to support the growth of the shrimp and tilapia, seaweed, crab, and also lobster. And this is several strategies. So if you heard about our plan to revitalize the pond in the North Sea of Java, so we try to revitalize almost 80,000 hectares of the tilapia pond. So we're trying to increase the production of tilapia and also improve the downstream sector, the cold storage and processing units. This has become our other strategy. And also develop the aquaculture villages in Indonesia, and also apply the modern technology to increase the culture productivity. So this is about the blue economy. I think this is fit to your conference theme, Gilbert. But the challenge in aquaculture, we know the disease. I think here we have Dr. Prakan from CP, so always talking about disease. I think this is still become the major threat in aquaculture, because 60% of the production is losses because of the disease in freshwater pond, and 40%, I think Dr. Ben Standen already talking about ESPND, 40% of the shrimp aquaculture is also losses because of the disease infection. And this because, traditional way of farmers to dealing with the disease, they're still using the antibiotics and also the synthetic chemical. So there is a misconception on the use of the antibiotics. So it's not only for disease treatment, but the farmers also using antibiotics to promote the growth and also prevent the disease, and also the disinfection and also control of this cyanobacterial bloom. So this is wrong conception about the antibiotics. So there are several alternative strategies that we can use to replace the use of antibiotics in aquaculture. So I think the biosecurity is very important, and then the probiotics and prebiotics, functional feed additive. I think Dr. Kabir already mentioned about the bile acid. So this is also one of the additives, and we can use this essential oil, enzymes, and herbal medicine. And also to early diagnostic and monitoring system is also important to replace the use of the antibiotics in aquaculture production system. One of the alternative strategy that I want to highlight here in this conference is about the use of the essential oil. I think this is a very good insight in aquaculture right now, because have a complex mode of action. We can enhance the appetite. Also, they have an anti-inflammatory, anti-parasite, and antibacteria, and also the antifungal in essential oil. And we know that the several compounds in essential oil, especially from oregano, they have different properties. They have carcinophylline and the anti-inflammatory effects, and linalool as the antifungal, and caffacrol and thymol, they have antimicrobial properties for aquaculture. So this is the type of one of oregano. We can see that this is Oregano vulgare. This is in international botany. They also known as the Greece or Greek oregano, because they have a high concentration of essential oil. So they consider as one of the best quality of the oregano. And this essential oil, they possess a strong antimicrobial, antifungal, and characterized by high caffacrol and thymol, 30-1, and also 50-1 maximum. And we know this caffacrol and thymol, if we talk deeply about this essential oil, caffacrol can also make a disruption of the cell membrane integrity of the bacterial cell wall. And this thymol, they also have a similar effect with the caffacrol. But this, the one that want to highlight in this conference is the thymol and caffacrol can also work synergistically. So to make this bacterial lysis is more faster if you are using this caffacrol and thymol together. So this is just to show you the picture of this Oregano vulgare plantation in Greece, and the picture of bee. This is the first half, the initial plant of the oregano. I don't know whether there's a laser light here, but yeah. And this first harvest will take place around 16 months after the oregano plants are installed. And this with the flower and leaf, this is ready to be harvested. So ready to be harvested to be used as the part of the, to get the essential oil or caffrocol and thymol from oregano plant. And normally people using the distillation process to get this caffrocol and thymol from this oregano plant. So they use the leaf and flower from the oregano to get the, the caffrocol and thymol from the oregano. So normally the separation is 100% natural without any chemicals or solvents. And we have two studies here that I would like to present in this event about the use of this oregano in shrimp and also in pangasius. I think this is a two prime commodity in aquaculture. So first I would like to talk about the shrimp. So we have two type of study. First, we formulating the feed with this oregano powder, and then second one, we are using the top dressing method. This is like a practical application on using the oregano powder in aquaculture feed. So for formulated feed, we are developed 4 diet. This is a isonitrogenous diet and isolipid, and we are using 3 inclusion level of oregano powder to contain 0.2, 0.4, and also 0.6%. And we are observed for 60 days. We are using this 1.0.5 gram for initial weight, and we are using 24 aquarium tanks, and we focus on growth and also health condition of the shrimp. So we also evaluate the total hemocyte counts and lysosome activity. And for the top dressing method, we are using the commercial feed, and then we observe for 60 days, and we are using 12 plastic tank and focus only for growth performance. And this is how we formulate the diet. We are using a very low inclusion of fish meal, 10%, and soy protein around 43%. And then we put the oregano powders, 0.2, 0.4, and 0.6%. And then if you look at the proximate analysis, all the diet have a similar crude protein level, and crude lipid level is around, protein is around 36%. All the diet have a similar level of protein, and fat is also have a similar level of fat percentage in the diet. If you look at the growth performance of shrimp after our students observe this for 60 days, even for the formulated feed or top dressing method, we observe a similar trend that the shrimp feed with this oregano powder, they have a better growth performance in terms of the final body weight and also thermal growth coefficient, percentage weight gain compared to the control without any oregano powder inside the diet. So we can see there's a significant difference here. And also with the top dressing, when we spray the feed with this oregano powder for 60 days, we also observe a similar trend with the growth of the shrimp, of the vaname. Then we can see that the shrimp that treated with this oregano powder, they can have a better growth performance compared to the control treatment. In terms of the survival rate, we can see that there is also a big difference in terms of the survival rate of the shrimp, either in the formulated feed or also in the top dressing method. So this is our observation in the shrimp for 60 days. And if you look at the total hemocyte counts as the first defense mechanism of shrimp, we can see there's an increasing number of the hemocyte counts compared to the control treatment. And for the lysozyme, because this is a natural enzyme that can break down the bacterial cell in shrimp, we can see the lysosome activity is also increased in the shrimp that treated with this oregano powder compared to the control treatment or without any oregano powder in the diet. Then it comes to our second study in pangasius. I think this pangasius also become a very good species for food security. So we also analyze this with the oregano in pangasius and also challenge them with the Aeromonas hydrophila infection. We have a similar methodology with vaname. We also using a formulated feed and also top dressing method. But the difference is for formulated feed, we have 70 days, but for top dressing method, we culture them for 122 days to get the consumption size of the pangasius. Indonesia only consume the pangasius in a small size, not like in other countries, probably they consume 1 kilogram, but this is 122 days is enough to get like a 200 until 250 gram of pangasius to consume. And This is we are using 16 plastic pond, but this is we are using the 16 concrete tanks with the different density of the pangasius. So this is also how we formulate the diet for pangasius. We are using cassava. This is to reduce the production cost. Sometimes we are using the local ingredients like cassava meal and also the oil and DDGS just to reduce the production cost. But we are using the oregano powder, 3 different inclusion level, 0.1, 0.2, and also 0.4% of the oregano powder. And again, we have a similar protein level here, and also the total fat is also similar among all dietary treatment in pangasius. And this is the growth performance of the pangasius after we observe them after 70 days and also 122 days. In this 70 days, we can see also there is a difference in growth performance of pangasius when we offer them with the oregano powder in the formulated feed for 70 days. We can see also the FCR is also more efficient with this 0.2 compared to the control treatment. They have a high percentage of this food conversion ratio. And if you look at the survival rate again, so you can see that the pangasius have a better survival rate compared to the control treatment without any oregano or essential oil in the diet. And when we also observe them in 122 days, this is our students collecting the pangasius and make a measurement for this pangasius in the concrete tank. We also have a similar trend where the fish, the pangasius that treated with this oregano powder, they have a good growth rate compared to the control, and also more efficient in terms of FCR, and the survival rate is also more or less is almost is better in the group of the oregano powder compared to the control treatment. And when we challenge them with the Aromonas hydrophila, we can see also better survival rate with the 0.1 and 0.2% of this oregano powder compared to the control treatment. So I think this is come to the end of my presentation today about oregano or essential oil or thymol or kafacrol. I think this functional feed with the addition of the essential oil is the best key tools in aquaculture, to support the growth and also the health of the aquatic organisms. And we can see in Vaname, they can also support the growth and also the non-specific immune function in Vaname. They can support the high increase in total hemocyte counts and also the lysozyme activity in shrimp production system. And also we also see the similar trends in pangasius, where the growth is also good in pangasius that have been treated with the oregano powder, and they can have a better survival rate when we challenge them with this Aromonas hydrophila. So that's the end of my presentation, Gilbert. I hope this fulfill your time. And thank you. I would like to say thank you to our students and also the EcoFarm Hellas to support provided us with this oregano powder in our research activity. Thank you so much.
Roger, thank you for the introduction. I know already a lot of you, but not all, because I'm senior. When I was asked to present here, I said, oh, it's a difficult topic, but I have also a lot of experience, not only in aquaculture, more in livestock, and the same topics are on both sides. So I could accept it. And when you go on the topics I want to mention today, it's aquaculture in the blue economy. We already heard this morning about it. Beyond the basic, what are precision feed additives? It's a question on definition. A phytogenic case study. I don't want to show you hundreds of slides and tables on trial results, but some interesting approaches and my key takeaways. Aquaculture and blue economy, a lot of you knows already more perhaps than I do, but I was last week in Kenya and I talked on aquaculture, and most of the Kenyan feed millers are constructing at the moment extruders for aquaculture and huge quantities. And it was for me amazing, because that's a country where you don't expect it, but at the end of the day, it's sustainable use of ocean resources, which is behind, while preserving the marine, coastal, and freshwater ecosystem. It's an economically growth and something which is of importance, and that is here in Asia as well as, for example, in Africa. It's for the livelihoods and the ecosystem health. And when I was the first time at an aquaculture conference in the US, I saw a lot of people from, for example, Africa, who are working on co-culture in aquaculture. So a really hot topic for all of us. And aquaculture by itself is a central pillar for it because, and that is something I have to mention also every time, it must be profitable for the farmer. Everybody who knows me knows already my sentence who is coming now. The profitability must be at the farmer side because he's paying our salary, and not only mine, also yours. It must be efficient, and perhaps a lot of you knows already 50 to 70% of production costs are feed. So we are really important to reduce losses or to improve efficiency. And yes, supplies over half of the global seafood is coming nowadays from aquaculture, and it's the fastest growing animal protein source. Perhaps some points which are also coming up. Global aquaculture must scale up because the population is growing. We have a rise in incomes. That means also more protein from animal origin. And it's also a dietary shift. And not only here it's mentioned animal protein, but also fish protein as a healthy source. Something I mentioned already before, it's still in production system. The volatile feed costs are important, 50 to 70% of the whole costs. And it will be more and more volatile in actual times. And last but not least, and that's something we saw also already in the discussion, disease pressure. Environmental regulations are coming up more and more, and consumer choices in antibiotic-free production. We mentioned that already, Romy mentioned it, but it's a hot topic for all of us. We are coming to something which is also of importance for everybody of us. It's a One Health approach. It's perhaps an old story, but we should not forget it. And when I come to my topic, I have to say phytogenics might support the interconnected health of people. Antimicrobial effects are already asked in the previous discussion. We should work on the shared environment and reduce application of it. And this is not only for the animals, it's for the ecosystem, and at the end of the humans, for us as humans. And when you go to the EU, you have every time the topic from farm to fork. So what we produce are human food. That's something which is of importance for everybody of us. And one thing I saw already at Tutti, the SDGs, Sustainable Development Goals, and I have to mention them too, and that because that's something of importance for us as company. We have choose 3 for that presentation, and that is zero hunger, good health and well-being, and last but not least, life below water. And now you can mention everything for human. No, it's also for the animals. Pay attention on it. And think every time about it when you work in our topic. Now we're coming to basic and precision nutrition. Basic nutrition is defined, and we made it in our company like that. There will be for sure other definitions also available. Don't misunderstand me. Basic nutrition, survival, and meeting baseline growth as topic. We have and we face high nutrient leaching and reactive treating diseases with antibiotic. And my colleague, Timmy Tope Alua he's located in Germany in the office, and myself, we were sitting together when we prepared the presentation. And I asked him, when you have that point, nutrient leaching, what do you think about it? And then he said, okay, that leaching of nutrients might be possible. And then I thought on a specific topic 5 years ago in our company, we developed for one multinational company an acidifier who is not leaching. So precision nutrition. But it's a topic you don't think directly on it, but when you recap again all those points, you are coming back to what you are doing. Precision nutrition means maximum efficiency, active health, metabolic management. And when I was studying a long time ago, we had in livestock one topic, and that was optimal protein nutrition for animals. And that is one part of the precision nutrition, but honestly, in aquaculture, I believe we are still far behind common livestock, but it's coming fast up. We have to look on minimal excretion and high nutrient retention. That has something to do with efficiency, profitability, and last but not least, sustainability. And proactive boosting immunity. I will show you some results afterwards on that topic. What are precision feed additives? They are used normally in low inclusion rates. That has also something to do with your feed formulation. You have more place in the feed formulation to put other things inside. It influences the biological pathway. Examples are phytogenics, we already heard that, organic acid binders, enzyme probiotics, amino acids, which are of importance. And Romy, I have to say, phytogenics are not only essential oils. There are several different possibilities involved and with completely different applications. So everything might be possible. You have different mode of actions and you have to pay attention on it. When you talk to people like me who are in the feed additive side, you have to ask on what can we do on microbiota? What can we do in regulating immune system? Oxidative stress, is that a topic for you? You have to challenge us while you are discussing with us. That doesn't mean that I can give you all the replies, don't worry. I'm mainly in sales at the moment, not in research. And something of important, strengthening intestinal barrier integrity. When you have the gut, it's the largest immunity organ of the animal. You have to think every time about this. So how do we measure value? So when I ask a feed miller, he will tell you immediately kilogram, price per kilogram of product and price per ton of feed. Is that the right measurement? I believe no. It's more on return on investment for the feed mill and the farmer, and perhaps even more for the farmer, and it depends if the feed mill is integrated. There are differences inside. we have to work on lower feed conversion rate. Feed conversion rate, you remember, about 50 to 70% of production costs are feed. That's one point where we have to go on. We have to go on, and that's also something we have seen already before. We have to work on improved survival rate because it boosts yield in production. We have to go, and that's something where we are really strong inside, proactive in health management. But we are no drugs. That's also something of importance for all of you. We are only a feed additive. And sometimes we forget it. We have also to produce premium products, antibiotic-free products, and they will come more and more, also in your area, everywhere. And that is an important point, and something which we have seen quite often on the trial side is uniform animals that make things easier to harvest and to process afterwards. It's an important topic. I want to present only some results, not a lot, 3 pages or 4 pages. It's a trial conducted here in Thailand at Kasetsat University, Pacific white shrimp, negative control, our phytogenic anti-ox. That's not an essential oil. It is going on at the end of the day to boost antioxidative immunological stress situation. Parameters are growth and survival rate, 8 tanks with each 500 liters, and after 60 days, a Vibrio challenge with a dose of 10 to the 4th. And I know Vibrio challenge are everywhere different, so when I have here 10 to the 4th, there will be also some with 10 to the 5 or 10 to 3, so we don't have to discuss that topic. It's only in that trial it was done like that. And I don't remember also why, but it was like that. So after 60 days before the challenge, we have seen huge increase in final weight. Survival rate was 4% up, and feed conversion rate was down. And that is perhaps something of most of interest for everybody, because that is what the farmer will see. When you go on immunological parameters, the farmer cannot see anything except if it's really working good. You see feed conversion rate as the point which has the largest picture for him. And after challenge, so at day 60 to day 90, we still had higher weight gain and still the better survival rate. So that are the topics which are of importance. After application of antioxidant, I'm with Romy a long time in discussion about that because it's an interesting topic under your heat stress situations here in Asia. When you are in Germany or where we have more or less no big aquaculture, or when you go to Norway, temperature is not so hot topic. I mention it like that, but here with heat stress conditions, it's a hard thing. And there you can really perform excellent with those products. I mentioned the word return on investment before as measure point, and when I saw my colleague Demi Tope calculated, and in the preparation of the presentation, I really looked again inside, but the values are correct. When you take all the advantages, survival rate, final weight, total biomass control, €3 per kg for shrimp, then you come with an investment in that under those conditions of €2.7 to a huge return on investment and to a gross revenue increase of 250 euro under those conditions in the lab. I'm coming to another trial, which is also practice-orientated. It was conducted at the Belgium Research Station in Aqua. It was also with wild Pacific shrimp, same product, same dosage rate, feeding trial 35 days with a salinity stress afterwards. Standard salinity was 20 ppt, temperature 27 degrees, and we conducted the trial from 20 ppt down to 0 ppt and measured afterwards survival rate of shrimp. What we have seen, I say it like that, at the end, they were all dead. But we have a huge time gap between the different variations. So we have some time to react on problems. And when we conducted the trial, it was really for us amazing to see also that we can assist under those conditions because we have never done it before. Coming back, and I am in time, so the path to precision. And everybody who knows me knows also what's coming now. It's a question of management also. So we start to understand the needs of our farmers. Operational challenges is the right word. So then they come to us or via our clients, a feed miller, depending on the axis, and then we discuss what we can do or not do. And honestly, when I'm in Europe, it's easier because everything is on a positive list, and whatever is on a positive list you can use. When you are here in Asia, each country has to be registered. It's a little bit more difficult for us to find the right solution. But in combination, feed manufacturer and us as additive producer and supplier, we come to an optimal version to come back to the farm level for a successful outcome. And something when I started to study, before that, I went 2 years on a farm to learn what farming means, because I'm not coming from an agriculture background. And something I learned during the first days is data collection. That's something which is of importance, and we have to collect the data on all farms, what's going on, to understand what's going on. And that we get a feeling what we do on the farm or what the farmer is doing. So this point is part of the full management on a farm. And if the farmer cannot do it by himself, we have to assist him. And that is one of the points. And without this, we cannot supply the best product for him. The feed manufacturer cannot supply the best feed for him because we have to measure. Measuring is everything, and that's part of the management. And with that, I'm in time. 1 minute left. Thank you. Key takeaways. Efficiency. Precision feed additives unlocks the hidden potential of standard feed. Profitability. Yes, it's important, otherwise nobody will do it. Sustainability. And it's not only on my can here saying we draw sustainable future together. It's also what I mean when we work on it. If we don't be sustainable, optimize performance, we will not manage it. And in the preparation, I found something again on the blue economy as chart, which might be of importance as graph. In the blue economy, the most powerful tool isn't just the feed, it's an innovation inside. And you see here, we need better feed, better nutrition, better production system, a better environment, and we come only to the better environment if we have that already in line, and then come to better life for all of us. Thank you for your attention, and if you have questions and I can answer them, I'm more than happy.
Thank you, Roger. Thank you. Good afternoon. Thanks for inviting and giving the opportunity to speak here. Can you hear me? Very good. Okay, I have 20 minutes, right? Very good. Okay. So today, I will be focusing on the urban aquaculture, and because this is a very interesting topics nowadays. Everybody looking at it and everybody thinking this maybe should be the future of the aquaculture for a big portion of production that we have now. These are a bit background about the company. Okay, so the company has been established in 2009, and we present in many places. We work with many farmers, and we are a farmer as well. Okay, I do have a farm in three farms for now. We have 2 farms in Singapore and 1 in Oman. So we do shrimp and trout. And shrimp, we have a different species. We work on Venami, Monodon, and Japanicus. Trout also, we are working on the rainbow trout. So when you talk about urban aquaculture, actually, it's a very interesting, I think, word, that how to define this, how to make it, sound correct is, I always say, means you produce where you sell. That I call it as an urban aquaculture. Means you are close to your customer. So you can build a farm nearby the Bangkok, or in Singapore, in Los Angeles, in Tokyo, wherever you want. But because close to the, this kind of place, there's a lot of limitation. I think I'm coming from a country that we have the highest limitation on the earth to do this kind of things, okay? So when you look, I think urban aquaculture, generally, it's going to be the, very, important in our future food security, because by looking at, we had a lot of difficulty during the COVID, and everybody suddenly feel that, oh my God, I have closed border, nothing can come in, nothing can go out, how I'm going to survive? Sometimes for a big countries, it's not really a big problem, but for a small countries like Singapore, it was a big challenge, okay? So, and also we have a lot of, I would say, requirement by the consumer, that sometimes the big producer, they may not be able to do it. So like, for example, for us, I have a small shrimp farm in Singapore. We were the first, I think, shrimp farm that got ASC certification in the world, which was the RAS and indoor farm. And that was a lot of surprise for a lot of people. But it was important because the consumer, they demand that. This is how the aquaculture, growing in terms of the, production and compared to the world population. And again, I'm not really going to tell you what does it mean. So we know that aquaculture, it is very, very less in terms of carbon emission that today is a very big problem. We have one minister in Singapore, she is in charge of all the production and everything, but I think she spent 90% of her time on this carbon emission. And then, okay, it's very important sometimes, because I have a course in Singapore, sometimes I teach in this TP, like a 3 days course. So we talk about entrepreneurship in aquaculture. And a lot of people, when we talk about profitability, the definition of profitability is always very, very different for everybody. And I deal with many farmers. So sometimes farmers, they do not really understand what does it mean by being profitable. So, and also, you know, profitability, it can be translated from many, many angles. If you are doing in Indonesia, your profitability factors, that the things that make you more profitable is different than somebody doing in Singapore or somebody doing in Oman or somebody doing in somewhere else. But at the end of the day, we always say, what you sell, you should be able to cover your cost and make a decent, you know, additional, we call it like a profit, your net profit compared to the rest of the things. Okay, that's very important. But the problem is that sometimes people, when they calculate this, they forgot a lot of factors. They just looking at the, we call it cost of goods. Okay, 1 kilo shrimp I produce, it cost me $3.50. I'm selling $4, $5, I'm making money. It's not true, okay? But anyway, so when you look exactly, these are the very important factors. But each one of them, it work on a different location with a different mean. You know, in Singapore, energy is very, very costly. So we pay for every kilowatt of the electricity, I think, maybe 35 cents. But in Oman, it's very cheap. If you go to another country, it's very, very cheap. So then you think, is that energy is my bottleneck? It depends. It depends on where you are doing this operation, okay? So it's really, really depends on, so sometimes, some place, I remember many years ago, somebody offered me a land in New Papua Guinea. Okay, if I go there and open a shrimp farm, how I can run it? I don't have there is no, you know, basic, you know, the road, I don't know the shipping line, whatever. So sometimes there are very, very different factors to make you think, is this what I want to do or not? Okay, so it's all about, you know, where you operate. But when you come to the, like urban aquaculture, like for example, if you want to run a farm in Singapore, I can tell you, definitely your energy is going to be one of the key, you know, factors. Manpower is very costly. But sometimes you say, if I run it like very efficient, so I can cut down, like our trout farm, we can be able to run the whole farm by using, say, 3 people to produce 3,000 ton trout. Because everything is automated, everything run by the AI or whatever. It's okay, Erika, it won't ring. Erika, it won't ring, don't worry. Okay, so we come to the production efficiency, because when you are running a urban farm, all the factors you have, like you look at your land cost, of course in a country like, say in Singapore, having a land is a big challenge because you cannot own the land. So like I have a 1.7 hectare land, so I have it as a lease for my lifetime. But it's not mine. At the end of the day, when I die, they're gonna take it. Or you can maybe rent it, okay? Some country like Oman, I have a 400 hectare land, I can develop whatever I want. So it's very different. When we look at from the perspective of the, you know, infrastructure, until the whole culture, okay, the production efficiency is really, really depends on many things. Like we know, FCR is always very important, how to manage the FCR, how to manage the, you know, the feeding, how to manage the disease, and mortality, like survival rate, is again very important. But sometimes when you look, you know, like when we do a high stocking density shrimp in Singapore, I really don't care about mortality because I do very high stocking density. I do 3,000 pieces of shrimp. Even if my shrimp 50% lost, I'm still okay because the cost of that 50% PL I lose, which I get the 50% that is more stronger and I can harvest, it will recover my loss. So you see, for some farmer, this kind of analogy does not make sense. If you say in Indonesia, I have a 50% survival, people will laugh at you. They will say, what is that? So you see, it's all really depends on where you operate. In urban farming, I really, like for example, our trout farm is very important. The survival is important, but for shrimp, I really don't care. Disease is the biggest challenge that you can have in urban farming, because you see, when we talk about urban farming, means you are talking about high stocking density. It's a high biomass production. You're not talking about 1 kilo, 2 kilo fish or shrimp. You need to be able to harvest a lot to cover your cost. Especially when it's come to shrimp. Shrimp is not something so simple, you know. Shrimp is the normal shrimp production. It's about, in the market, 1 kilo per square meter, 2 kilo per square meter, means 20 ton, 10 ton per hectare. But if you want to be successful in a farm that we have, my farm is only 5,000 square meter, is a culture area. So we have a 7 pond. I need to produce at least 8 to 10 kilo per square meter to manage my cost. So you see, it's a very different game. So productivity is very important, but on top of that, disease, the biggest challenge in this kind of place. Because if you get the disease in, it's very difficult to take it out. It's not like simply you can just go and, you have to shut down many things, okay? Then you have really, like in shrimp, for example, we shorten the culture period. But again, it depends on what size of animal your customer wants. I mean, Singaporean, they don't like to eat small shrimp. I mean, if I sell 15-gram shrimp, they don't like it. So it's a challenge, how we shorten the culture. So I need to have a fast-growing animal. Fast-growing animal, we have something in Thai, we say Thailand, grow fast, die fast. So you have a problem there. So you want to grow them fast, you may lose them fast. So then you have to balance. You know, you need to really balance between these two. You need to be able to grow animal in the shortest time, but you make sure that you don't give them too much stress, you know. You don't need to have, you know, like in a urban farm, like if you talk about genetic, I mean, like genetic that's a separate discussion. We can have 2 hours talk about that. But generally, when you talk about genetic, I don't like animals that they are hardy. Hardy animal usually grow slow. We want animals that they grow fast, but they are not so weak in the, you know, resistance to disease also, okay? But you don't need too hardy animal. You need much more faster growing animal. Then you can be able to rotate, and you cannot harvest in a urban farm cycle. Is a big mistake that a lot of people do. You cannot say, okay, this cycle I harvest 20 tons. So what do you want to do with that? Who you want to sell? We sell every day. So if you want to make profit, you have to be able to harvest every day. So then, like our shrimp, we send to market on a daily basis from a 6,000 square meter, 5,000 plus square meter. How I should plan my farming? So you need to be able to harvest every day. Like, so our production is about, like, assume 120 ton per year for that 6,000. So I need to sell per month 10,000 kilo shrimp. Means per day, somewhere about 300 kilo. So if I miss, means I cannot. And that is the very big challenge. You know, that is not something everybody, because in Singapore, if I go today, I say, okay, I harvest 30 ton shrimp. The reason they buy my shrimp because it is fresh, because it is live. I mean, I don't sell live, but it is like captured in the morning, delivered in the noon. So now I have a 30 ton shrimp, I put it in a freezer, and I sell to the customer. My cost in Singapore per kilo of shrimp, $8 to $9. Indonesian sell farm gate, $5. How I can survive? Okay, these are the things that are very important. Sometimes people don't. But even for our trout also the same. Our trout farm design, it is designed based on the daily harvest. We don't do one shot, I don't know, 10 ton trout, 20 ton trout. There is no way such a thing can work in a urban farm. Urban farm means you supply on a daily or bi-weekly, by daily or every 3 days, whatever. You cannot say, okay, I'm an urban farm, I'm doing a farming in New York and I'm selling every 3 months. doesn't work, okay? So, I mean, these are like more like a technical things. Like sometimes like a waste management. I mean, in Singapore, if I want to throw a paper, I have to be careful. It's not like simply I can throw everywhere. So imagine you are running a farm and you have a waste. How you want to manage that waste? Okay, these are all challenges. Maybe in India, Indonesia, I can just discharge everything, okay? Wow, don't have much time. So we have to definitely manage. So we use a lot of automation. We use a lot of, you know, system that it's help you to reduce, okay? And I mean, this is not our trout farm. I don't know, we have some picture I will show you. But this is a common RAS system. But like for us, our RAS system that we have in Singapore is a very, very low, you know, we call it very low water exchange. And we use a denitrification system because of simple reason. Denitrification system will help you to reduce your water exchange. You cannot do just only normal nitrification, okay? Okay, and then big problem. I remember I was in San Diego last year, June. I was giving a talk in a RAS Tech. And then a lot of people sitting there like they are all like a guru and god of the RAS system. And when I was telling them that how much my farm cost me to build, they were telling me I'm joking. No, it's not a joke. CapEx, it will kill you. You understand what's the meaning of CapEx? Capital investment, huh? It will kill you if you don't manage it correctly. Many of these salmon farms you see around the world, they fail. Sometimes not fail because they cannot produce. They fail because they are too expensive to produce. Okay? So CapEx should be very, very low. OpEx should be reasonable. Okay? And that's what we have done in our farm. It's very different. So it is definitely, you know, it's a farm that, you know, you spend less, you grow the animal, your operation cost in terms of per kilo of fish is reasonable. So you can supply on a daily basis, okay? Yeah, like this. So these compartments, it separate the fish, so you can harvest at different sizes on the given time, because there is like 6 compartments we have. Okay, so always the challenge is number one is a high investment cost, because when you talk about farm that you need to build nearby the city, the first things come, how much will cost? There's a lot of component inside that will give you exactly the picture that, oh my God, it's going to cost me like, I don't know, like my farm is 3,000 ton production. It cost me around $45 million. A similar size of farm somebody else built in somewhere, they spend 140 million. That's a very big difference, you see. It's a 80 million difference on the, you know, the expenses. So you have to recover that 80 million, right? How you want to do? You have to pay from your profit. And that is what a lot of people fail. Because they can, you see, when you build something, you need to watch your pocket. I spend this money and I need to run. This is the simple things in shrimp farming. I do shrimp farming since, I don't know, 30, 35 years. I always believe many shrimp farmers fail not because they cannot operate, because they don't have enough money to operate. So it's not just only having the farm. You need to have enough money to fail at least 4 times. If you can fail 4 times and still you have money in your pocket, sure you can survive. But some people, even one cycle they fail, they are bankrupt. That's not the right business model. Okay? Of course, temperature, I mean, like in a country like Singapore, our outside temperature is 30 plus. Indoor, I have to keep my water at 16. I visit many farms for trout and salmon around the world. It is not really very difficult to do this if you know how to run your chilling system. It's not difficult. It is not a big bottleneck, which a lot of people think, oh, how I can cool the water? No, it's simple. It's very simple. Of course, electricity, that how many kilowatt hour per kilo of fish you have to spend. That's the determining of your cost. Like you say, I spend, for example, I know for hours, like around 4 to 5 kilowatt hour per kilo. So it's 50% goes for the chilling system, 50% goes for the system. Okay, now, how you divide that correctly and you look at your pricing, okay? And then of course, waste management. So if I produce 3,000 ton of fish, I feed 3,000, because our FCR is 1. So we feed 3,000 ton of feed, and I will have a lot of poop. So what am I gonna do with that? Okay, but this is a good thing. Good news is for trout is that it's a freshwater poop. So I can use it as a fertilizer, I can use it for, if it was a salty water, is a problem, okay? The production cost, yeah, like in shrimp, one of our big challenges is size variation, because when you do stocking of, 2,000, 3,000 pieces, definitely you're gonna have some big, some small, so it's a challenge, okay? Regulatory. Like in Singapore, we have 26 agencies, and each one have their own saying. So I have to fulfill everybody. It's big challenge. So I mean, like because of us, now in Singapore we have they call it Farm Act, something like that. So that's why we have like some regulation coming, like our SCDF means our fire department, our, MPark, our public utility. So they are trying to understand what this industry about. But you need to have a really thick skin to pass through those things. And then of course, farm supply. I mean, Singapore, you want to buy one pump also, you cannot. You have to import. I mean, luckily I have office in Bangkok, other places, so I can buy and bring it. But sometimes it's a big challenge. So this supply has become always for urban farming is a big challenge. Yeah, so we have all this certification. Is it good to have certification? To me, it doesn't matter. I mean, to be very honest. I told them also, I know all the boss of these people. I mean, I say, I really don't care I have ASC or not, but consumer, they care. Is that make me a better farmer? May not. Okay, let's be honest. But it's requirement. We need to have it. So it's like, I represent Singapore for an ISO standard. So sometimes we have every week we have a meeting which I don't attend, only like once a month. So we have talk about all this ISO. So I can see, oh my God, how we built all this certification. Is a lot of things is more theoretical rather than the practical. But it's the book. You need to have it, okay? I think that's all. Am I on time?
Thank you very much, Hassan. That's a great insight into the difference between normal aquaculture, what we think is normal aquaculture, and producing in an urban area. And what surprised me most was how you have to be prepared to sell daily, sell fresh to get the maximum, and you're not just harvesting. The floor is yours.
Thank you very much, Roger. Sawadee Krap. Good afternoon, everyone. It's a pleasure to be here today for this event, VIV Aquatics. And thanks to Roger and Tuti for the kind invitation. Today, my topic of presentation is regarding brewers as a byproduct and how it could turn us a profitable blue economy. So, as you all may know, globally, the seafood consumption or demand is increasing. So nearly 50 to 70% of the fish or crustacean which is coming into our table are coming from aquaculture sector. However, due to too much reliance on these marine resources, along with the fish meal prices, volatility in the fish meal prices and oil, and this is pressure is pushing the industry to look for more alternatives. One such possibility is to look into circular bioeconomy model, where more functional, sustainable, and cost-effective ingredients could be applicable. So, just imagine today you are having a chill beer, and somewhere else around the world, the farmers are not able to cope up with the feed price, or they are not able to have the feed. So what if yesterday's beer fermentation could be one of the feed ingredients for the future food for aquatic species? The solution may already be sitting at the bottom of the fermentation tank. Globally, and every year, millions of tons of brewer's yeast is produced, and they are more often used as a nutrient source. They are sold as a cheap source in the livestock industry, mainly to ruminants, beef cattle, all this industry. But sometimes they are discarded even as a waste. So just imagine if two massive industry like brewery and aquaculture industry is working like a circular economy, where high performance biologically acceptable aquaculture ingredients could be created from a brewery byproduct. This could be highly valuable. This is because brewer's yeast is rich in protein. They have higher other kinds of nutrients as well, mycotoxin binding effect, immunostimulant. This is one of the most popular effects coming from the yeast because of its beta-glucan. If it is processed properly, this could partially replace the fish meal as well. So more or less, we could consider that it is not just a feed ingredient. It could be considered as a functional nutrition. Brewer's yeast is rich in B vitamin sources, and they have other nutrients as well, including B. I told you about B vitamin, amino acids, residual hope ingredients are there, and mannose oligosaccharides are there. So brewer's yeast is belonging to the species Saccharomyces cerevisiae. They are having a thicker cell wall, basically due to its fermentation process during the beer preparation, because they will have a thicker cell wall to defend this anaerobic condition. That means compared to the bakers whose molasses yeast, they are undergoing aerobic condition, here anaerobic condition. That means they will have a thicker cell wall, nearly 25 to 40% of its total dry mass is forming as the yeast cell wall. So at LIBOR, we have been upcycling the brewer's yeast since 1954, which is more than 70 years. And we have been producing valuable and healthy ingredients for human, animal nutrition, even biotechnology application, including agriculture aspects we are working on. So our motto is to give our brewer's yeast a second life, which is fitting into the sustainable and circular economy. So where does our brewer's yeast coming from? We are receiving our raw material from breweries which are following the German purity law. This is one of the oldest law sustaining in Europe for the food industry. And according to the German purity law for the beer, they can use only 3 material, which are barley, water, and yeast. And hops are added there for giving the aroma or flavor to the beer. So we are receiving the material, we are receiving the yeast from here, from the fermentation tank, and then we are bringing up to our factory. So liquid yeast, when we are receiving, it is around 10 to 12% of protein. Then we are bringing it to our northwest part of Germany. Our production plant is located there at Yankton. These are some of the facilities where we are doing the autolysis process at LIBOR. This is the overall production process. So the liquid yeast coming to our factory is undergoing a process called autolysis. And then we will be separating the liquid portion and the solid portion. Solid portion is going as a yeast cell wall. And if you are purifying them again, you can get highly purified beta-glucan. And the liquid portion forms as the yeast extract, or high in nucleotides and other kinds of palatin factors there. We have different kind of products there. And all these products are spray dried. That means it is fitting well into the aquafeed industry, heat stable. So we have a wide range of products for aquaculture industry, coming from 100% pure yeast, that is sometimes going into the ornamental fish industry, yeast cell wall, beta-glucan, which is highly purified, nearly more than 80% purity. And then we have autolyzed yeast and yeast extract. These are more or less going into the pet food industry because they have higher palatability factors. This could be useful for aquaculture industry also as a chemoattractant or palatant. So more or less, yeast cell wall is the most popular component from yeast in aquaculture industry. They are basically popular because of its immune stimulation activity, prebiotic functions, and mycotoxin binding ability. When you have a mannan oligosaccharides as an ingredient, they could easily bind with certain gram-negative pathogen. Same like Ben was talking today about, Dr. Ben talked about the binding capacity. They can effectively bind to E. coli, gram-negative pathogens like E. coli and Salmonella. So as you may know, vibriosis is one of the key diseases in shrimp. They could also have an effect. More or less, it prevents the gut colonization of the negative pathogens, thereby preventing the toxin to go and destroy the intestinal walls. So overall, it can have a healthy gut system because of its prebiotic function. So we have done several trials. This is a prebiotic trials we have done it, the effect of prebiotic. It was an in vitro trial we did in UK. So where we take 4 different species of probiotics, Bacillus, Lactobacillus, and Pediococcus, and we've used only the yeast cell wall as the carbon source, only carbon source there. So we can see here, after 2 to 3 hours of time, all these probiotic bacteria are going exponential. That means they can effectively utilize the cell wall as a prebiotic form. Again, we have done another trial in vivo condition where we have fed only 2 kilograms of the yeast cell wall using the rainbow trout model. Then we look at the mucosal and digester region for the microbiota using high throughput sequencing. When we look at the trial data, it was quite interesting. We could find out that the pathogenic potential bacteria were reducing. Meanwhile, other probiotic potential bacteria seems to be significantly improving. So overall, when you have a yeast cell wall there, it could have a good gut system. Even yeast cell wall has the property to improve the gut morphology. They are quite often one of the most important functionality in the livestock industry. They are looking into this because they can absorb better nutrient. So here you can see their microvilli density and the goblet cell count was better. So this is also a very good impact from the mannan oligosaccharides. So overall, I would recommend the application of yeast cell wall, especially if you are looking at gut health improvement programs. And if you have a dysbiosis, this could be the right solution, yeast cell wall. So quite often in recent times, we are discussing about immunity and diseases. One of the beta-glucans are actually one of the ingredients coming from the yeast cell wall is beta-glucan. So they are one of the most powerful immune enhancers or modifiers in nature. Okay? There are different forms of glucans available, whether it be from the cell walls or the bacteria, mushrooms, fungi, even some plant materials like oats, barley. They all have their glucans, but they have different linkages. So only highly purified beta-glucan with a 1,3,1,6 linkage, which is having a backbone of 1,3 glucans, can exert immune modulatory properties. Not all beta-glucans can have this function, including the solubility, the structures, purity, how we process it. All this have an effect onto the beta-glucan, effect onto the animal, aquatic species. So they are recognized by the immune system as a pathogen-associated molecular patterns, thereby stimulating the innate immune response. So usually they are very tiny particles which can pass through the immune cells or M cells of the intestine, and the macrophages, which is the first line of defense mechanism, having certain receptors, special receptors, they can detect the beta-glucan and start triggering the intracellular signaling cascade mechanism. Some of the pattern recognition receptors I have mentioned here, and Dectin-1-like receptors seems to be the primary beta-glucan receptors in fish. In shrimp as well, as you may know, they don't have an adaptive immune system, so entirely they have to depend on some kind of immune stimulation. So it has become necessity to stimulate or modulate them, the immunity, is, for example, like beta-glucan, so that they can fight against the infection, both for cellular and humoral responses. So recommendation for the beta-glucans, I would recommend, say that usually for the challenging condition or highly stressful conditions, they could be very effective. For example, like handling stress, transportation, environmental changes is happening, winter to summer periods, it could be very useful. And even for the pathogenic pressure, then beta-glucan functions better. So always remember, it is not a medicine. So like you get a disease and then using, you will not see that effect. You need to consider it as a prophylactic measure. That means well in advance. Also, this could be interesting as well for the fish. If you are providing the beta-glucan as a dietary supplement, they could improve the vaccination efficiency. It has an adjuvant effect. So we have done several trials, but I just pull in only a few of them, just to show that for high stocking density or intensive culture practices, beta-glucan could be very helpful. Here we have took this one, European eel as the species, and stocking density was 50 kilogram per meter cube, and we fed only 200 milligram per kilogram of feed. This small dosage is because, as I mentioned to you before, 1316 beta-glucan is more purified, highly purified, which is close to 85% purity. That's the reason this small dosage. So you can see there, the immune response seems to be much higher in 4 weeks as well as for the 8 weeks. Even for the specific antibody seems to be higher. This is what I was mentioning just before, the adjuvant effect. So whenever you have a beta-glucan supplement into the feed before the vaccination program, it could have an adjuvant effect. And it can increase the specific antibody levels, and antibody secreting cells are much higher. So this was a recent trial we have done in Thailand, where we have taken 2 different doses of beta-glucans, 200 grams and 400 grams, under 2 different conditions. One, we have provided the shrimp with a stressful condition where high stocking density and low water temperature was provided. On the other hand, we provided higher temperature and lower stocking density. Interestingly, on the white shrimp, we found out that at a transcriptome level, all the immune-related genes which we have taken seems to be upregulated, especially during the stressful period, you can see there, under high stocking density and lower water temperature. It's the same condition when it is a moderate or normal condition, you don't see that much of effect, but still that upregulation is there. So this is why I was explaining to you, under challenging conditions, including disease challenges, they could have higher performance. Autolysis is a process where yeast uses its own enzyme to break down the cells. So during this autolysis process, they will be releasing free amino acid, small peptides, and even nucleotides. Until upon recently, nucleotides or nucleic acids were considered as a non-essential ingredient. But recent trials and information suggest that this is increasingly being considered as one of the major ingredients to defend against the stresses and even for the diseases. When you are doing the autolysis process, they will have higher digestibility. This is one of the key. So they could be also used as a palatant. For the fish species, this glutathione or choline will be quite good for the liver function, metabolic functions. All these factors will be very supportive. Nucleotides are the building blocks of DNA and RNA. They are in a simple form or a simple sugar form. So they play a major role in the cellular metabolism and cell signaling pathways. You should know that there are 2 different mechanisms where the organisms can synthesize nucleotide, which is de novo synthesis and salvage pathway. Both of them are they are okay during the normal phases. But whenever there is a disease challenge or stress, the synthesis will not happen properly. So it becomes necessary during those times, especially for the high physiological stressful events, or rapid growth is there, reproduction or immune challenges, nucleotide will be very helpful. And also some of the key tissues, for example, lymphoid tissue or intestinal epithelial cells, they lack the capacity to synthesize nucleotides. So I already mentioned to you before, the glutathione and other free amino acids are there. This will be very helpful as a chemoattractant. So recommendation-wise, I would suggest this is quite applicable for the shrimp industry, especially in the nursery stages, because the larvae or post-larval period, the biological rate or metabolic rate are much higher. Cell division happen to be very quicker or faster there. So dietary nucleotide will be very helpful during that period. And also they have a very short digestive tract, so this will be very helpful because highly bioavailable nutrients are there. This is one of the unique features of breweries, which is hops effect. So when you drink a beer, actually you feel very calming effect. It's actually coming from here, hops. So this could be very useful for the animal industry as well, because they have polyphenols, beta acids and alpha acids. So this is used in the livestock industry, especially in the swine or poultry, against, how do you say, sometimes the pigs always bite their tails. You might have noticed it when under high stocking density. So this polyphenol will be able to calm them down, same like we drink beer. They calm very much. Even for the poultry, they always prick each other, the feathers, everything. So this will be very helpful. But for aquaculture industry, I would say this is quite unique, bacteriostatic effect. They can suppress the bacterial growth, especially gram-negative pathogens. So it could be considered as a natural antimicrobial and replacing antibiotic alternative. So overall, I would conclude my presentation saying that breweries is just more than a byproduct. Transforming comparatively low-valued, high biomass brewery byproduct into functional feed ingredient could be fitting very well into the circular blue economy model. With that one, thank you so much for your time.
Thank you, Pradeep. Do we have any quick questions? Beer and aquaculture? I think that has a certain ring to it. Yes, I think there's somebody down the back here.
Yeah, I saw that in his bag. I have seen it once. Okay, thanks, Roger.
Okay, thank you very much, Pradeep. Thank you.
Best presentation I've seen in my life.
Thank you for the beer.
Thank you, brother.
Okay, we're moving right along now. Dr. Ram. Dr. Ram is from the Asian Institute of Technology. I'm sure he's familiar to all of us here. He's going to speak to us on driving blue economy growth through precision aquaculture with mechanization and automation for better efficiency and profitability. It's a subject we addressed this morning and we're coming back to it this afternoon. Dr. Ram earned his MSc and PhD in aquaculture at AIT Thailand with postdoctoral training at the University of Stirling in Scotland. An affiliated faculty and former Aqua Centre Director of AIT, he has authored key aquaculture texts, published extensively, led EU-funded projects, trained professionals worldwide, and received the AFS Gold Medal for contributions to aquaculture education. Dr. Ram, the floor is yours, sir.
I guess both will work. Thank you very much, Roger. Thank you for inviting me for this presentation. It's my pleasure, and good afternoon to everyone. So my topic is about blue economy. There's so many things to cover. Let's see. The outline is a little bit of blue economy and precision aquaculture, or let's see how I see from my point of view. So blue economy means all the areas where we have water, and probably 70% of the people are living, in coastal areas. Not only in the seawater, also fresh water. There are so many rivers, so many reservoirs, lakes, and people were, settling maybe along the rivers. Even in the past, when there were no roads, that time waterways were the one, going from one place to another by boating. You may hear there is a floating market in Thailand, very popular. So that was the tradition since the beginning, long ago. So blue economy is all about aquatic environment and how we exploit. So 70%, more than 70% of the water surface, earth surface is covered by water, and a lot of activities are there. Human civilization started from those areas, and how we can utilize resources, those resources for our benefit, and also how we can conserve so that they last longer forever in the future. Otherwise, we are facing already problems. So aquaculture and fishery is the main from our side, but there are others also happening in those areas: tourism, shipping, biotechnology, maritime, mining, oil and gas. All these things are happening, but something like more than $1 trillion economy, and it is going to be double maybe by 2030. That's what blue economy masters are saying to us, let's say. So from our point of view, aquaculture and fisheries is the main source of protein, more than chicken, more than pork, and when you combine, actually it is even more. And aquaculture is growing fast and fastest food production sector, we are saying. If you combine both of them, we are consuming more than like 160 million ton, whereas chicken is around, I think, 140 million ton we are consuming yearly. So aquaculture industry is huge. So many people may not still realize these things, and policymakers, especially in many countries, they don't realize. And when you go those countries, people working for fisheries or aquaculture, they are sitting in a corner, like a small area and with a small budget, right? But when you look at the global picture, it should be the biggest, actually. So depends on the country, like Thailand, probably it has Department of Fisheries. Maybe there are more than 20 units under that department, but in some countries, no, very few people are working. Human resources is very limited. And also, in terms of scope, the production of the protein through aquaculture or fisheries need to be double. What we are consuming here at the moment is 20 or 21 kilogram per capita, right, per year. But the fish or fishery products are good for health, so it should be 1/3 of our protein intake if we want our health is good. So that at the moment it's only about 17%. That means we still need to double it in terms of protein intake. And more than 3 billion people are consuming seafood, aquatic food, but that's the data FAO is saying. But what about other 5 billion people? If they also want to consume a lot, then demand will be huge. That's why our industry is really in a, let's say, booming phase or need to boom a lot. And if you look at the total aquatic food consumption, China, of course, is the biggest. and Indonesia is second, and India has the highest population, but consumption is low. Imagine if the Indians also start eating like a Chinese, seafood demand will be huge, right? Because population is huge. Same way, other countries also, European countries, America, all countries, they like to consume seafood or aquatic food. Then imagine if the consumption is increased double, the production is needed to be a lot. So just example, and Asian countries are already consuming more than the world average, right? Thailand, I think interestingly now Malaysia probably one of the highest fish consuming country, something like a 60 kilogram per capita per person, per year, and which is like 3 times more than the global average. So what we need actually to produce more, so we already understand the need or demand from our society point of view, community point of view, and then we need to do more research and development, and then develop the technology, apply, and then make more efficient what we have now, and more productive and more profitable. Only then this industry will grow, right? So basically what is going on at the moment, how we classify aquaculture, especially pond aquaculture, this is I'm referring to. Extensive aquaculture, which is like no input. You just have a water in the pond and you have a fish fingerlings and then you harvest. And same as semi-intensive, and you go more inputs. Everybody knows these things, super intensive. But on the other hand, from knowledge point of view, I like to categorize aquaculture as like a blind aquaculture, because we don't know many things what is happening under the water, right? There are so many things, so many microbes. Without understanding, we are many farmers or many people are trying to, just dig a pond and then put the, fill with the water and then put the fingerlings and then feed and harvest at the end. So sometimes fish may die, sometimes fish don't grow, so that happens, right? So without understanding anything, we are doing aquaculture. Sometimes we know a little bit about water quality. Some farms measure maybe DO temperature, a little bit of these things, and then add feed. And again, some farms are really doing a lot, and they understand. Just earlier we saw Farsad presented urban aquaculture, where they have to control everything. So huge knowledge is there, but it's still how you can control all these things. What I think is still there are missing things. A lot of knowledge we'll see later. So more knowledge you have, less risk you have, and more control you can do. Otherwise, fish die, we don't know how they die, why they die, they just, farmers cry only. So the main thing is, how can we generate more knowledge, more understanding about our culture, our aquatic species that you are choosing for your business, and make a decision based on the water quality parameters, yeah? So if you look at our culture system, you have so many things there. Fish or shrimp, whatever aquatic species you culture, is affected by so many things. How can you make all the environment suitable for that fish to grow fast as possible? And from the point of view of feed, I think many people here are from the feed companies and feed supplements. So traditional knowledge, we try to provide all the nutrients what fish needs, including protein and amino acids, carbohydrate, oil, fat and oil, and then vitamins and minerals. But nowadays, more and more people are interested in some additives, supplements, enzymes, all these things. How can you make sure all these things are in a single pellet, or every pellet has all these things? How can you fix? And each species may have different requirements. So this is the problem. How do we have knowledge about these things for each species? And also within each species has it's like a developmental stage, starting from egg. So Kabir was saying, even from the egg stage, we can provide some nutrients. So I also had thought earlier about tilapia egg. We are trying to do something like that. So also, it's not only the feed. You prepare how feed is digested, how it is actually, whether it is attractive or not to the fish, by color or by smell or palatability, and also when it goes to the mouth and then stomach, and are there enough enzymes to digest, or anything, pH or suitable temperature is there, and also all these digestive system and absorption, what helps to absorb better. So digestibility, all these things. So instead of, in addition to providing the nutrients in the feed, we are working on all the, digestive system, whole digestive system, gut analysis, how many microbes are in the stomach, millions of types, right? That's why so much knowledge is necessary. Do we have all this knowledge to make sure your aquaculture, gives the, best production, productivity, and also profitability? So we try to do simple experiments to determine the nutrients. This is one example, like vitamin C for during the monosex tilapia production. Sometimes our hatcheries use maybe 10 grams per kg, sometimes 20 grams. Then we try to, okay, let's do some experiment, and we find out, we pinpoint here, so actual is 15.79. So if you have a wide range of treatments, then you can do the regression analysis and pinpoint, okay, this is the right precise level of feed, certain feed nutrients. Same way we do this type of experiment as I'm in the university, so students I guide the students to do the experiments. And also we get some products from European companies to do the experiment. Like we had a Biomin, we have Lucta, we had Delacon, we had Bionte. Many companies were giving us the products to test in our facility. So this is the way how we can exactly give the answer, rather than this is higher and this is lower, that's why we should use this. No, we think we should have a little bit of wide range of treatments, so that you can pinpoint, okay, this is the right amount, right concentration in your feed. So this was one of the phytogenic feed additive we tested. Then we found like a survival, and then the amount is exactly pointed out here. So same way, there's another one for the shrimp we did, and we also pointed out this one was mycotoxin agent in shrimp. And then there's not clear how much we should use, because this product was tested in poultry, was common in poultry and pig, but it was not used in aquaculture. So we are given this, funded by that company. So we pinpointed here. We had treatments here, 4 levels of treatments, and then we find out something like a 1.4, and then it gives the highest daily weight gain possible. So this is the way how we can precisely find out the nutrient levels. I don't know, most of the research, very few research you can find like this analysis and designing this way. This was another one in Rohu, and this was a probiotics in Rohu fingerlings. And here also we pinpointed out like a 1.5 gram per kg probiotic was the best for this stage. So how many, there are so many 500 species of aquaculture, and all these species need some sort of information like this. All these probiotics, all these supplements, nutrients, vitamins, minerals. There's a huge area to do the research, to pinpoint, and only then there will be a precision aquaculture. So we know at the moment, I think there are so many species without this information available if you search in the internet. And people are talking about now, AI will answer everything. No. AI will filter the information what is available in the internet. If there is not available, or what you'll give something else, I don't know. So first thing we need to do the research and find out, and then put that information in online so that it will be available and AI can catch. So this was another one. It was, we also tried insect meal, field cricket to replace fish meal. So which is burning topic at the moment. There are so many types of insect meals are available. And we found out something like how much you can replace fish meal. In some cases, like sometimes you don't get right answer because you don't have enough wide range of level of treatment. But in some cases we use this broken line analysis. So here 75% you can replace, here 61%, but this is like this is a hatchling stage, this is fry nursing stage, and this is fingerling stage. So these are different stages. So different stages will have different impact. That's why how can you, without research, how can you decide? If you go to who make the feed formula for poultry or aquaculture, they will give you like a big table. But how those information they collect, I don't know. Sometimes they take reference of another species, similar species, something like that. Sometimes even take reference from the poultry. Is it suitable or appropriate or not? That's the question. So this is another one. Sometimes research is there, but still they don't really pinpoint what is the suitable, appropriate label. Sometimes they make mistake. Not all the scientists are equally competitive in terms of data analysis, experiment design, and then data analysis. All these are problems sometimes. Okay, so we tried a lot from our side so that the students can learn, and those students can be good in the future to help aquaculture industry. Same way, like a temperature, dissolved oxygen, all these figures, how can you optimize so that all these species grow fast and then give you profit. Like some people do research like this. This is just example only. There are some indication here, but still you could do like a modeling and then find out equation and then find out the exact what is the exact temperature for these species. But this has not been done, even in published papers, which we could do actually. Same way, like in tilapia, temperature is somewhere here. So we just look here roughly, and we say maybe 33 degrees Celsius or something. But still, we can precisely say this is the right, temperature for tilapia for this stage, something like that, for good, highest feed intake. Same way, dissolved oxygen. There are so many things, information not available, or even they have done, but still how they interpret the results also is very different. And then not only these nutrient and water quality parameters, even sometimes we try to do, like this is one example only. In the community we had a project, and in rural areas, the ponds were like a 100 square meter pond, 200 square meter pond, whatever people had, land available to make a pond. Then we try to analyze what will be the right size of the pond for the rural people to manage. So we came up with something like that, like a 350 meter square pond size is the right size for the people who do small scale aquaculture for their family consumption. So this was a project in Nepal some time ago. We had women in aquaculture. Women were doing the aquaculture and harvesting fish, selling for their family purpose. So same thing we try to apply in other countries. So if we have this type of information, then you have certain model by input and by what time. If you have this level of input, and then also with the temperature, environmental condition, then we could predict, okay, this may be the productivity. Only then it would give to the people who want to do the aquaculture. Otherwise, many farmers are actually suffering. They are losing money. Sometimes fish die, sometimes something happens, Okay, this time temperature was too cold, that's why fish die. So they have to pair and try again another time. So all this because of lack of information, lack of knowledge. How we can, fulfill this knowledge, this is the problem. So if you look at in aquaculture, salmon, tilapia, pangasius, crabs, these are the major species. How they are managing in terms of management also, like a salmon this was I think in Scotland. So they have the way to feed exactly how much they want, because they have a camera at the bottom, on the surface also. The salmon, after they eat and they are full, they go down at the bottom. So camera will see, and then whether feed or not feed. So this person is controlling the feeding by mouse, clicking the mouse. So this type of automatic systems have been developed already. And then that's why salmon has, I think, about 1 FCR. That means 1 kilogram of feed can produce 1 kilo salmon. So which is the probably most effective. Although in green water you can have even below 1, but natural food is there. And also automatic, like a robotics has been used to call out the diseased, weak salmon, and also by color, by size, grading. All these are possible. They have been doing already. Also in large scale, I think I saw in China also using machines to make it efficient. Whereas mostly in Asia, we are still struggling like this, manually digging the ponds, hardly maybe excavator to dig the pond. So this is the situation, how we can help. And this is feeding in Thailand. You can see still feeding in a very traditional way. But aquaculture is growing. I don't know, it's haphazardly or sometimes there is problem with the environmental problem, something. That's why there is actually difficult situation. Shrimp culture is a little bit managed well, but it also had a big problem of EMS. So many diseases occur earlier. There is a monodon until 1995 or 96. Then Banamai came. Banamai again has a problem. So why this goes up and down? Because of this lack of information, lack of knowledge, how people are managing, right? That's why more research is needed. Otherwise, we always face sometimes boom and bust, right? And tilapia is another species. A lot of things going on in Thailand. You might know very largest hatcheries in the world happening in Thailand. And technology is going all over the world from Thailand. And initially, this hatchery technology was developed at AIT. And we had an agreement with a private company, which is now largest in the world and exporting all over the world. Like this technology is going all over. And also some machines have been used for packing and also counting using a computer screen. So to make it more efficient, like a packing in 3 hours time, they're packing like more than 500,000 fingerlings, something like that. So these things are happening slowly, and there are machines to count the fingerling. Counting small fish is so difficult, right? Always you can make a mistake easily. And also stocking and also simple machines have been now developed, like using even solar power for feeding. So you can set how much you want to feed per day or per how many times, something like that. So some feeding things are happening, but not much automation is there. Yeah, this is one example also. Some farms are themselves doing some using machines, and this is a catfish harvesting in Chachoengsao province in Thailand. And they have a more simple grading machines. So you see how aquaculture they are managing, some way people are struggling. So and also even carrying fish down from here. This is Mekong River, using motorbike to pull, using pulley. Some farmers' innovations, farmers, their struggle I can see, but I don't know why a little bit of mechanization has not been done. But if you do, we did this in East Timor with the World Fish Program. If we do a little bit, then productivity could be increased by 300, 400%. We have done this. You can see when we started, productivity was like this. Then after one phase, we got like a 300% increment in productivity. A little bit of management, training to the farmers. And finally, we got something like a 400% increment in productivity. So it's possible in the community as well, not only with the advanced technology applied by the companies. And also there is another thing, like how can you work out actual profitable level of feeding or any inclusion of nutrients. Let's say not necessarily the highest growth, highest survival is the most profitable one, right? You have to work out having how you increase every unit of input should cover how much you get additional output, right? So every unit you add should be covered or more, it should be more, output should be more. So economic principle has not been applied either. So this is one example we work out here. If you increase every $20 baht feed increment, then your output is here where it can cover only. Then at that point, total will be higher. So these things have not been applied. And more importantly, nowadays, people are talking about this system where you can measure, you have a sensors that can measure temperature, pH, salinity, all these things, and then at certain temperature, the feed intake increase or decrease. Based on that, then you make the program how much feed is needed for that type of things. And then also size of the fish, density of the fish, all can be maybe in the future this may come, and also using drone for the feeding. These things have been talked about. I don't know how any farmers are using this yet, but this is the future maybe, which can increase, enhance efficiency, and then. So in conclusion, what I think is you need to know species, particular species has different requirement, and then in terms of nutrition, in terms of environmental factors, and then how you can apply machines or automation things, and then your people are the most important thing again, to apply all these principles and then mechanization these things. Only then you'll have the best profit, best production, and best profit. Thank you. We do a lot of training. As much as possible, we have tried our best. People are coming from Europe, America, Africa, in Thailand. So you can see making feed, a lot of things going on. We organize a lot of training, including sea bass, shrimp, prawn, snakehead breeding, catfish breeding, tilapia, all these things. So thank you very much. That's what I wanted to present here.
Thank you very much.
A bit long.
A wide-ranging presentation, but one I think we all appreciate. And data, very important to understand data before making a decision. Okay, thank you. Any questions before I move on? Any quick questions? Okay. Well, we come to almost the penultimate presentation. Bülent Kökü is going to, from Catalysis of Madrid in Spain. This company was established in 1989, and Bülent is going to talk to us on evidence-based aquaculture health, molecular activation technology, MAT for short, real-world performance results. He's a marine biologist and scientific advisor with over 30 years' experience in aquaculture, marine bioprospecting, and natural bioactive compounds. Expert in product development, veterinary and agricultural supplements, and scientific consulting. He's the managing director of Catalysis SL and co-author of multiple peer-reviewed publications. Thank you very much. The floor is yours, sir.
Thank you so much. Thank you. Pointer. Okay, thank you very much. As I'm introduced, I'm a scientific catalysis a scientific manager, and I'm a marine biologist, and I used to work in my life more than 10 years in aquaculture, but especially for pharmaceutical industry. I used to work as a bioprospection expert around the world for different sectors, but especially for pharmaceutical sectors in invertebrate aquaculture farming. That was one of my expert area. And in catalysis, we are a Spanish company, European company. We are under control of European Union in product development or product standardization. The company has applying good manufacturing practices, good laboratory practices, and the company has a ISO 9001 certification, for example. It's a pharmaceutical company. This pharmaceutical company started with CSIC. CSIC is one of the most important research center complex in Spain. From mathematics to engineering, from bioscience to ocean sciences, astronomy, they have different research group there. Under the name of Dr. Martin, a biochemistry group discovers a technology. This technology, we call it molecular activation. This molecular activation technology is a biocatalytic process. Increases the therapeutical effects of the natural molecules without changing their chemical structure. This biocatalytic process makes this changes in the molecule, but without any structural change. That energy makes the molecules more reactive. These molecules are able to act more therapeutical than the normal stage. So that's why the company established and started to produce different health products for human first, dermatological products and systemic product, and then we started with animal health. We produce different products for farming, poultry, swine, and aquaculture, of course, for fish, for shrimp, for crustaceans production. So I'm here just to share these experiences with you. Using this technology gives us always important benefits. You don't need to look for new compounds for new diseases. Diseases are always present. So instead of, let's discover a new compound, the already working compounds, we can make it more effective. That is the philosophy of our company, and we apply this technology using and doing this model of work. So you have salicylic acid, you have glycyrrhizin, you have malic acid, you have many important natural molecules that we can use for the treatments, and before that we can make much efficient all these molecules and amplify their therapeutical effects. That's the one we do with this technology. And thanks to this amplification of their biological indications, we use very low concentrations. We don't need to use very high concentrations of this molecule. Like, let's go with salicylic acid. Salicylic acid you can buy from the pharmacy without prescription, 500 milligrams. If you have higher inflammation, you need to probably use 1 gram and more. So you need prescription. So without rising the concentration, the dose, and the time of using of these natural molecules, what we do is we amplify their therapeutical effects. It's not 1 or 2 times amplification. It's 10 times, 100 times, even sometimes more, depending on the chemical factors of each of these molecules. Every molecule has their own pH, double carbon links, etc. So we design an electrical field and we inject electrons. During this process, we make more reactive all these molecules, and all these molecules can participate in these metabolic activities. We call it therapeutics, and we have these clinical results. And by this, even you can increase the dose, you don't have any side effects. That means that you don't destroy any part of the organism, kidney, digestive system, just opposite. And you have very fast action when you use this product, very fast action. And all these results, these increased activities, you don't go with one molecule. When you check the formula for our products, Catalysis produces, they have multi-molecular formula. That is natural molecules, for example, amino acids, vitamins, in all this environment we work. As you can see, we have these reactors in our installations, and we inject electrons without changing the chemical structure. We have enhanced activity in our molecules. Without changing the chemical structure is important. So we have VIV Aqua. That is the first product we will talk. This product is coming directly from the human health. We have fully experience in human science, human medicine, full of publications in British Medical Journal, Liver International. The same product with a little bit different, changing the formula, acting also in terrestrial animal farming. From that, we created also VIV Aqua. The same product for the similar problems acts in different species, aquatic species, fishes, echinoderms, mollusks. And in fish, the product, thanks to this multimolecular formula, it is antioxidant, immunomodulator, not stimulator. Immunomodulation is definitely different than immunostimulation. It's not like, for example, beta-glucan. It works as immunomodulator, biologically prepares the immune organs, and the product works when it's necessary. The organism produces immune cells. It is antiviral, direct antiviral, working on the animal cells, and it is anti-anemic. In crustaceans, more primitive organism, but it works as antioxidant, immunomodulator, antiviral, and hematopoietic also. So this product, we can see some of the molecules, active ingredients, thanks to this chemical synergy, works in between as antiviral, antioxidant, anti-anemic, immunomodulator, and biocatalytic. Biocatalytic especially is important. That means that the product is able to increases digestibility of the feed, and in the same time absorption and better use of all these nutrients coming from the feed. And also the product is able to increases the synthesis of different enzymes, proteases, lipases in pancreas. So it's able to also increases the digestibility, so better feed conversion without changing any thing in the protocol. It has, this product, a very good synergy with probiotics. Any probiotics, these experiences is coming from one of the important clients in the east of Asia, and especially they use this combination probiotic, that is VIV binder and feed all together. The product is able to stimulate the growth of probiotics and the better gut health and the better immune system of the organism. The product can be applied directly in the water because it's water, a liquid form, and can spray on the feed in the farm, but also it can be included in the feed mill directly. We have experiences, we already created type of feeds, and they use as a functional feed in different areas, different countries. This is the basic recommendation protocol of the use of the product in different stages, but that is just a recommendation. And important companies, they just apply this product, they adjust in their conditions, and they got better results. Normally, it's like 4 milliliter per kg of feed in different areas, in different moment of stress. And also, if you have, for example, transportation, you can use it directly in the transportation water. So there are many applications, and it's very easy to understand. The second product we'll just mention, VUC Detox. VUC Detox is a probiotic product, but enriched with some natural molecules for arranging the broken gut system in the same time that you colonize the gut system. So the philosophy of this product is doing in the same time 2 or 3 things. That means that I have probiotics here. Whatever the name of the products, in fact, is not very important. This we use in these species, but also we have already existing probiotics in the gut system, but not very high level, let's say, and the animal has a problem, they're broken. And these molecules, what they do is, first they act as a local antitoxic. They are able to neutralize the toxins of the pathogens. In the same time, regulate the pH. In the same time, fix the broken epithelium, especially thanks to glutamic acid and sodium butyrate. So that's the mechanism is, during the regulation or fixation of the gut system, I also enrich the gut with probiotics. So I don't expect everything from the probiotics. I help to these probiotics for their colonization using these natural molecules. In the same time, it's an orchestration and getting very good results. The product compromises just in 3-4 days, starting to colonize the gut system. Another product is Asprit, also designed for different problems. The importance of this product contains 3 essential oils. All the molecules I'm talking are activated peptide or molecular activation technology. So we know the mechanism of all these essential oils, thymus, eucalyptus, mint. They are more powerful in our product. So I'm just gonna giving you some evidences in shrimp farming. We have these 4, well, in fact 3 products, because in some countries, or we use it aqua registered as VIV, but they are exactly the same products. We use it detox and Aspirip, these 3 products. In AHP infection, and the using of this product, how is able to increase cellular immunity and viral infections and and here AHP, the using of the product against AHP, as you know, AHP is not it's a microsporum, is intracellular parasites, just slow down the growth. It's a very important problem. That is poor feed conversion, sometimes high mortalities, and transmissions because of breeders, and secondary infections. Always when you have AHP, you have secondary diseases, viruses and other bacteriological problems. And that normally is losses. We have the animals or farms, but not for commercializing, it's just for keeping them alive. So this product, in the first experiences, I'm sorry that the places of the presentation are changed, but I will just mention here. These are the experiences from Bangladesh with freshwater shrimp. In this study publication, they use the product against also bacterial viral infections, and in tanks directly in the drink fresh water, and but also in the feed of the organism, and the dose in 10 ppm in the water, and also in existing without, closed system 3 ppm Artemia, and also they used in prepared feed and transportation. And in these results, what they've got is 17% survival and 17% more body weight length, and 15% more. This is especially just for the benefits of this organism. And when we check the metamorphosis, we have also better metamorphosis, better weight gaining comparing to control group, and better shape in the organism. And comparing with and without, pigmentation was better, less parasites in the VIV aqua group, better larval movement, less, no cannibalism, and better metamorphosis. And in this study that they did in Thailand, my colleagues are here also, they can talk more about this. In this study, they designed the study, the feeding in different concentrations, and what they say, feed plus 4 milliliter of VIV feed plus 10 milliliter, they had the good results in 7 days and 21 days. And parameter was THC, DHC, and phagocytic activities. And we can see here more THC cells and semigranule cells and better phagocytic activity. And using VIV detox vet and aspirine together for combating EHP, in this mechanism. Detox combines as a probiotic, bioactive molecules together, a better proliferation of probiotics and fighting against pathogens, better restored gut health, better feed conversion, and improvement in water quality. In the aspirate side, essential oils are the substitution of antibiotics mainly, and fighting against secondary diseases especially is important, like Vibrio. And in this challenge, we had 7 days results, 14 days and 21 days. As we can see, we have this concentration, 10 milliliter per kg of feed together, VIV detox aspirate 1:1. We had a very good results in AHP cases because the animals were able to grow properly. As we can see, post-challenge 21, 18% more survival and 11% more survival, and G5 and G2, which are a control group, control negative, control positive, and the best results in 10 ml per kg. And growth parameters 51 days. Also, we can see that a better feed conversion in G4 and a significant reduction of feed costs also. So, and another experiences is a challenge against white spot syndrome. This is from Mexico. And in this study, publication, they use also against directly in the laboratory and shrimp, and as we can see here, better results in the results. This is generally because of glycyrrhizin containing of the product. Glycyrrhizin is a powerful antiviral, and many different species is non-specific antiviral molecule. So in this case, we have these applications and we know these mechanisms in developed organisms, in human, in animals, but and also a different type of virus in this environment. And in the experience of shrimp, what they've got is 4 groups, and in the long treatments, we have very good results. And in this group, 17 days before and 5 days post-challenge. As you can see, it's the time of using this product. And here is the results. We have a good defense mechanism, stable counts, as you can see, and high initial counts. And that is median days is much better. So that we can see the result of these results. No microscopic white spot lesions, no necrotic cells, equal to unchallenged control. So these results also showing, confirming in different areas, the product is working as a powerful product against white spot syndrome of virus. So these are the result of this presentation in VIV Aqua. And Bangladesh cases, we have 17% survival, 25%. VIV cases is VIV cases which we use it Aqua also, and Vietnamese. We have better THC, GSC, and dose-dependent phagocytosis activity. Combination of using VIV detox aspirate, we have in Vietnam cases 18% more survival and better feed conversion and more humoral immunity. And VIV Aqua by itself in Mexico experiences and more also survival and less injuries against white spot syndrome virus. So this is the product that the recommendation how to use. This is a totally adaptable product that you can adapt, they can use in different conditions. So thank you very much. This is my contact details. If you need more information, also we will be joining to Orbit or stand, and I can give you more information calmly and on all detailed information. I'm sorry because it was just trying to rush and giving you a general information. And I would like to also thank you, VIV Aqua team, and for all your invitation for all during all these years, and we meet each other and we help each other. And thank you for your all your support to this industry worldwide. And thank you very much for inviting us. Thank you. Thank you.
Thank you very much. Some very kind words. I think we've had a lot of information this afternoon, and I'm sorry to say that our 10th speaker, Sven Olof Malmqvist, out of Sweden, could not make the trip over. So he's absent today due to the circumstances in the Middle East. So right now, we're going to finish a little bit early, but I'd like to do a quick question and answer session. But before I do that, we have somebody in the audience here who I think we should hear from, and it's Han Jun Lin. He's the founder of Giant Biotechnology in Taiwan, and he's worked with the Ocean University in Taiwan and has come up with some very interesting ways of controlling disease in shrimp and other species. And I've asked him on your behalf if you'd just produce 2 or 3 slides and take us through, just to give us a bit of an insight. And of course, afterwards, you can meet with him if you want to follow up in any detail. But he's not on the program. It's just an opportunity that I thought we could make. But the floor is yours for 10 minutes.
Thank you, Roger. Good afternoon, everyone. My name is Han Jun Lin, just like Roger introduced. Thank you. Actually, I'm a professor from National Taiwan Ocean University, but I'm also a newcomer in the business world. So I'm also belongs to the biotech company called Giant Bio from Taiwan. So I'm very happy to listen a lot of very interesting talk today, and I really learned a lot to meet the thing of this topic, how to make it profitable and also sustainability in the blue economic in aquaculture. This is a very important issue that I'm also always thinking about that. In my career, I'm a professor from the university. We invented a lot of very fancy works. But when we try to adapt our technology to the market, usually we are challenged. People were asking that we don't want to increase our cost when doing the aquaculture, and we don't want to change. You know, cost not only come from the money, but also come from the habit to apply the products. So the farmers, they don't want to change their experience. So that's why that some traditional way, they also have so many strong power to control the market. For example, we all know that antibiotics is not good for the environment. So many governments try to ban antibiotics use, but it still take a great market share in the market because antibiotics still very efficient and very convenient for farmers to use that. So it gives us a lot of challenge as scientists and also as an entrepreneur for a startup in this industry. We try to convince farmers to use new technology. At the meantime, they don't need to change their habit and they can achieve the similar effect. So this is my research group and my company is focused to do. So we are very new, so that our company only started from 2019. Right now it's 6 years. But during our technology was invented almost 10 years ago. So for the last 5 years, we are working very hard to trying to mass production our product and try to introduce our technology to the market. So because I'm not on the schedule, so I have to run very fast. So our solution for antibiotic replacement is, we call it hermeticin. So what is hamedacin? This is actually is a phytochemical with nanocarbon technology. So this is a breakthrough alternative on antibiotics. So if you are interested, you can search my name from the scientific publication. We already published more than 20 papers, and then many paper was cited all around the world. And we find that with nanotechnology, some natural ingredient, they can enhance their ability more than 2,500 times, and they are still very stable, and they are very safe to animals. So this is a perfect solution for aquaculture. So let me give you some example. This is not only our publication paper, we also use our product, and we ask third party to check, to do experiment for us. So this is the result from Canton University from Vietnam. And they, in their test, they use very high dosage of VIV, HPND VIVs. So you can see the control group, the mortality is almost 100%, 90% mortality. But using our hamedacin ingredient, only 0.1 ppm, you can see difference. And the survival rate increase according to the dosage and the day you use. And this is just immediately used only 7 days, and then you can see the effect. So right now this product is already mass production and was sold in Vietnam, Malaysia, and Japan. And we look forward for a more commercial collaboration, and you can see some case report. This is in Taiwan. You can see that the shrimp, when they're feeding with animal feed with hamedacin inside, the GUS VBO number is very obvious decrease. Only 3 days or 5 days ingestion is different. This is an example from China. The shrimp is already yield. So usually when the shrimp was infected by VBO, usually you will have nothing to do with them, but with feeding with our ingredient in high doses, the condition turn better. And it's very easy to see the difference. So this is a control group of shrimp. This is a test group of shrimp. This is a case from Japan. Just feeding this feed ingredient, you can see the guts that become more dark and very sick. This is a phenomenon that the shrimp is much healthier in their guts. So I think antibiotic-free shrimp aquaculture is not a dream. It can be achieved now. So this is my short introduction. Thank you very much.
Thank you, Hanjin. I thought that was an intriguing product or development that Taiwan is bringing to the fore in shrimp farming. And as we know that antibiotics is something we've got to address. The question of antibiotics is something we seriously have to address as an industry because we're finding that the FAO is on our case. FAO is determined to drive antibiotics out of animal livestock farming, and we can't move out from being included in that group as aquaculturists. So we have to find alternatives to antibiotics, and that is maybe controlling diseases before it gets to the stage of that, or maybe we need products like this or like others that work after the effect. But today's series of presentations, I mean, I've made some notes here. I'm sure we all have made a few notes. And the words that spring to my mind are essential oils. We've had several mentions of the importance of essential oils in the diet for fish. From now on, I would say fish and shrimp. We also had several mentions of data, how important it is to know where we are and to actually determine what the data is telling us before we make investment decisions. We have also obviously mentioned throughout technology and the importance of technology and how we must adopt new technologies if we're going to achieve some of those figures that we heard later on this afternoon of reaching something like doubling consumption from Dr. Ram from 20 to 40 kgs of feed, did you say? And improving the availability of fish from 3 billion people to 5 billion, and also to address the lack of knowledge that we have in some of these areas of how to go about achieving this. But under the topic of blue economy, it's not just about water in what we presume like the ocean or the view of a river or of a lake. There's all sorts of different aspects to blue economy, including aquaculture in urban areas. And we heard some insightful things about how maybe we should be trying to produce our aquaculture where people are prepared to buy it from us fresh. And maybe that's something we should be looking at to address these population increases that are likely to appear in urban areas, particularly in Africa and some Asian countries. So I've made a lot of notes here. We had very important presentations from Benedict Stanton this morning on Vibrio endotoxins, which I thought was, to my mind, a breakthrough that his aquaculture department has asked and received the support from within DSM to focus on aquaculture in a meaningful way. We had lipid utilization from Kabir, that we all have something to take away from that. We also heard one of the things that also resonates with me is that when we talk about minerals or we talk about ingredients, they're not all the same. Just because we talk about the type of mineral or the type of ingredient, that we've got to be very specific. We've got to ask more questions and find out the data behind some of these terms that we use. So, I can't mention all the presentations, but I have mentioned some that hopefully will trigger your imagination as well. We've been videoing today's presentations. They will be available to the speakers, and if they feel that we can present them more widely, then we'll do that. But hopefully that will be the case, that we can put that on the aquafeed.co.uk website. But one of the pleasures I have at the end of the day is giving out speaker certificates as a thank you for speakers actually taking the time to share their knowledge with us. I think we're very privileged to have such dedicated people in our industry who are prepared to delve into their knowledge and share that with us. I know we all have a product to sell, and there's something that's supporting us in terms of why we are here. But these people have gone to extraordinary lengths, in my view, to explain who they are and what they do and what's important to them besides just talking about their product. So Joe, if Joe's still here, there's a certificate here for you, Joe. I think my colleague is going to take a picture of this handover.
Get my good side.
Grab the camera.
Later on we will.
Oh, okay.
Everybody else.
Yeah. Okay, just yeah.
Thank you.
Don't forget to come back. Benedict, Ben.
Thank you, Roger.
Because I will take a good picture.
Thank you. Okay, Dr. Kabir. Just a small thank you from all of us. Okay, Dr. Rami.
Thank you.
Okay, Dr. Bernard. We should actually have him out of the sleeves.
Thank you.
Okay, Prasad. Pradeep. Dr. Ram.
Take and see.
Oh, yes, please. You'll get to have a view of one of these.
This is the way, yeah?
Thank
Thank
you.
you, thank you.
And Bullet. You want to open it too. Thank you. Thank you very much, everybody. Okay, we wanted, Tootie, do you want to take a picture of
the group.
Yes. Is that everybody? So if you'd like to be in a picture that appear in International Aquafeed, please come up the front.
But I'm too tall, so I need to be. I'm waiting that the people that are going to fix it up.
Let's go now.
What a crowd.
Yay! All right.
Just one more.
Mine is one is the one in the magazine. Thank you.
Thank you very much, everybody.